Thank you, Nikita. So we'll start off by doing some introduction to the shell, like I've said, and I'm going to just stick to, again, like I've mentioned in the beginning, to what's on the Carpentry site, again, so that if you miss anything or I fail to cover something maybe really well or really clearly, you can always come and peruse the content on your own and see if maybe the way that they've presented things, help you a bit more. But for the most part, we'll stick to what's here anyway. So hopefully nobody gets lost along the way. There may be times when I jump from one section to another section to maybe demonstrate something if I feel that perhaps it's best for me to demonstrate it at that point rather than when the lesson suggests. But that will happen in very rare cases. For the most part, I'm going to follow things as it is here to help you also follow on your own if you're struggling to maybe keep up as well. If at any point you get lost, you have a question, you don't understand anything, please do just use the raise hand function. So raise your hand or type in the chat box and say, sorry, guys, I'm not following along. Can you please stop and backtrack? We are 100% happy to do that. Please don't feel like any question is a silly question. When you get started with any language for the first time, whether it be a coding language or a spoken language, there are sets of rules you have to learn. There are mistakes that you will make. There's a learning curve that you have to get over. And it's fine, it's fine to make mistakes. It's fine to type in things a gazillion times incorrectly and get it wrong 100 times before you get it right. That is fine. And if you get stuck and you need help, just let us know. We are happy to stop, backtrack, and let's also just be patient. If there is a participant on the call who maybe needs a little bit more support, let's all be patient with each other because we want everybody to have a good learning experience. And even if, we take long to sit with issues and troubleshoot, that is fine. If we maybe can't cover all of the content that the lesson suggests, I don't think that's a problem, as long as the content that we do cover, we cover well and everybody understands really well, so that you can maybe move forward into some of the other lesson content even on your own later on. That is my opinion of how I'd like to run the session. But if at any point you want me to speed up, then please also just let me know via the chat. Just say you're going way too slow, speed up a little bit, and then I can do that and we see how everybody manages. But I've said a lot of things now. I'm going to shift to the lesson. I hope everybody's more or less got their shell lesson data now. If not, just please do let me know via the chat, or let us know via the chat that you're still struggling and you still need to download that data so that we don't move on too far and you get completely lost along the way. But hopefully you guys are all fine and you've got that data and you've got your shell. We'll open up the shell soon, but let's just do a bit of background on the shell and why we teach the shell and why it's such a useful program. So most of us know that when we interact with computers, the common ways that we interact with our machines is through a keyboard, a mouse. For smart devices, we have touchscreen interfaces, and now more and more we are also using speech recognition systems. So that's not really unfamiliar to any of us. We're all quite familiar with that. And we all are probably very familiar with GUIs. These are graphical user interfaces, where we give instructions by clicking a mouse or using sort of menu-driven interactions, but it's very point and click or point and drag. So that is how a lot of Windows systems are set up, and even things like our Linux systems are more and more becoming quite GUI-based. But while this makes things very intuitive to learn, so it's much more intuitive to use a GUI than a command line interface, it's a very clunky and poor way of giving your computer instructions. So the Carpentry gives this example that you imagine following a specific task, right? Say you're doing a literature search. As part of this literature search, you have to copy the third line of about 1,000 text files in over 1,000 different locations and paste it into a single file. Now imagine that task on a Windows or GUI-based operating system. You would have to click on a file, open the file, copy out the third line, put it into the next file, then go to the next directory and repeat that 1,000 times, right? So essentially, the GUI-based interface scales very poorly when you do tasks, especially repetitive tasks. So they say here that if you had done it this way, you'd probably be stuck at your desk for several hours, maybe even several days. But one of the main benefits of the command line interface is that it is a scripting language. So it allows you to script repetitive tasks. You get to do it automatically, much faster, and a task that would have taken you several hours can now take several seconds. So it scales a lot better. I'm just quickly checking the chat box because I do see some things coming in here. Please, guys, at any point, if I do maybe miss something in the chat box, just interrupt me. Nikita, maybe just interrupt me and stop me and just maybe point me to the chat box. I may not always see it very, very quickly, but I'll try and respond when I am prompted.
Yes, no problem. I'll keep an eye on it.
Thank you so much. Okay, great. Right. So that's just a bit of background on why we would want to use a command line interface or scripting language versus a GUI system. And I think this is quite intuitive. So I'm going to move on now to the shell, which is a program where users can type commands and it then translates those commands in the computer system, et cetera, et cetera. The computer then understands what we want it to do. So the most popular Unix shell is the bash shell. And remember, we're even using git bash today, which is kind of like a flavor of bash. Most of us that are using Linux would use Ubuntu, and Ubuntu also comes with bash, Ubuntu bash. And this is referred to as the born again shell, just basically called that because it's derived from a shell that was written by somebody called Stephen Bourne. And it is actually the default shell on most implementations of Unix. And on most Windows systems as well, the default shell is usually the bash shell. So I've mentioned before that using the shell and also learning the command line will take a bit of time and effort to learn, because unlike a GUI, there are no point and click options. There are very few to none. And so everything that you want the computer to do has to be done with a set of programs or commands, and we'll go into how to use those commands, navigate your file structure today, and get you to do some very basic things. But it will give you a bit of an introduction to using the command line and a bit of a foundation that you can then build on. So you're not going to learn everything today, of course. You're not going to be doing some major scripting. We're going to be doing the basics. We're going to be laying the foundation, and then we'll hopefully scale up from there throughout this week. Right. So we've done a little bit of intro to the command line and shell, not much, but the best way to learn is to get onto the shell. So I'm going to stop sharing my screen now and just start sharing my git bash window. I would like you all to now also just open your shells, whether that be on your Mac or Linux system or your Windows system. I'm using git bash today. So if it doesn't look exactly like what you are seeing, hopefully you are still able to follow along. Most of the commands will be the same or very similar. They might change from system to system slightly, but we'll try and also talk you through what those changes might be and look like so that we don't lose anybody along the way. Right. So again, just by a quick thumbs up, do you all have your shell open? Do you need a couple more seconds to get that open? Okay, one thumbs up. Okay, seeing a few more thumbs up. So I'm going to guess that we can keep going for now. Great, okay. Seeing quite a lot of thumbs up, so I'm going to keep going. I'll try and keep the chat box open over here next to my terminal so that if there are any major issues that crop up very quickly, hopefully I don't miss that. But let's just explore the shell a little bit. So your shell might not look exactly like what I've got up on this window, but you will see some information about the machine that you're on. Maybe it's your username. You can see here that I'm obviously on my personal laptop and I'm on a Windows 64-bit system. You might have this exact, or not exact information, but very similar information if you're on a Windows and you're using git bash. But if you're on Mac or you're on Linux, this will look slightly different. But at the very least, you should see something. There's nothing usually that's going on the shell when you just open it. But what you will see is what we call a prompt. And on git bash and on many bash shells, the prompt is this $. It might be something else on your machine, but just know that you will see a prompt, and that just means that the shell is basically able to take your commands. You're basically able to start entering your commands. You'll also see what looks like a text cursor. It might be vertical, it might be horizontal, it might be a block, a blinking, flashing block, but that tells you that the shell is ready to accept something from you. It's ready to accept input. So hopefully you can all see that already. Now we're going to start by typing our very, very first command. And again, what you see on your machine is going to look slightly different. Your very, very first command is just going to be ls. So ls, that's it. That just means give me a list of what's within my current working directory or my current directory, wherever I'm sitting in my file system. So if you guys could all just type ls, you'll see very immediately that I'm on a Windows system. It's very messy, clunky. There's things all over the place. I'm also very messy sometimes with my files. So you see lots of funny things here. You see my documents, you see some colors, at least on my terminal. On your terminal, particularly if you're on a Mac or a Linux machine, you might not see any of these colors. You might not see any of these little characters at the end of the files, but we'll show you how to add a lot of this visualization soon. But first, just start by typing in ls and then give me a thumbs up when you've all typed in ls and you've gotten a listing of what's in your, hopefully, home directory. When you open up the shell, you should be in what's called your home directory. I'm going to speak to you about that in just a second and explain what that is. But again, okay, I'm seeing some thumbs up, so you guys are following along. Fantastic. Now we've done ls. But I just want to demonstrate to you all what would have happened if we had typed in this command incorrectly. So if we had typed in ks, ks doesn't exist. It's not a command that Linux understands or the bash anyway understands. So it's basically told me this command is not found. So whenever you see this returned, it means that bash is not understanding the instructions you're giving it, and that command actually doesn't exist. And so immediately you'll already know there's some type of spelling error or something is wrong with the way you've structured your command. Now, we're going to move on to navigating our files and folders a little bit. But before we do, I'm just going to quickly shift back to the workshop website again. I just want to talk you through the sort of example that we'll be working with throughout the rest of the Unix lesson. So you'll see that as we progress with the Unix lesson, the lesson refers to NAL quite a lot, or NAL's computer or NAL's pipeline. So I just want to talk you through what NAL is, so that you understand when we're referring to it. It's a fictitious person with a fictitious file system, but just so that you know what we're referring to, so that you don't think in your mind, but who the heck is NAL and what files are they talking about? I just want to read this to you, because basically the whole of the rest of the lesson is structured to get you to this point. To help NAL, essentially. So this is just a typical problem that they outline. They say NAL, Nemo, is a marine biologist and has just returned from a 6-month survey of the North Pacific Gyre, where she has been sampling gelatinous marine life in the Great Pacific Garbage Patch. She has 1,520 samples that she's run through an assay machine to measure the relative abundance of 300 proteins. She needs to run these 1,520 files through an imaginary program called goostats.sh that she inherited. On top of this huge task, she has to write up results by the end of the month so her paper can appear in a special issue of Aquatic Goo Letters. The bad news is that if she has to run goostats.sh by hand using a GUI, she'll have to select and open a file 1,520 times. If goostats.sh takes 30 seconds to run each file, the whole process will take more than 12 hours of NAL's attention. With the shell, NAL can instead assign her computer this mundane task while she focuses attention on writing her paper. Now, the next few lessons essentially explores the ways that NAL can achieve this. More specifically, it explains how she can use a command shell to run the goostats.sh program using loops to automate the repetitive steps of entering file names so that the computer can work while she writes her paper. Right. So this whole scenario that they've outlined here is essentially what we'll step through. Hopefully by the end of the Unix lesson, we'll get to write our little script called goostats.sh that null needs, right, to loop over files 1,520 times. So everything will kind of feed from this example and back into this example. So I just wanted to make sure that I've read this to you so that you're not lost when we move forward. Right, so I'm going to switch back to my terminal now. And now we'll start navigating through some of our files and folders. Now, navigating files and directories is the next lesson that you'll find from the home page. Remember, we're following all the content as is, as structured on that home page. So if you want to follow along on your own machine, just click on navigating files and directories, and we'll be continuing on from there. Okay. So we'll start by saying that the part of the operating system that's responsible for managing your files and directories is called a file system. The file system organizes all of our data into files, which can hold information and can also hold other directories or subdirectories. So you can think of this in the same way as a folder on your Windows machine, for example, or any other machine can hold subfolders and files. The file system is exactly that. Now, we have several commands that can be used to inspect, rename, create, delete files, move files, copy files, and explore a lot of the files on our systems. And so that's what we'll start to do with this particular episode of the lesson. We call it an episode. You don't have to worry too much about that terminology, but yeah, we call all these different sections of the lessons episodes. So if I refer to an episode, that's what I'm referring to. But let's start by printing our next command. So we've done ls, we've just done one command. I now want you to type in pwd. And what pwd stands for is just print working directory, essentially. So if I run it, you will see that it returns /c/users/Verena, because I can't spell my own name clearly. It should have said Verena, but somewhere along the way when I made my user profile, I spelled my name incorrectly. But on your machine, if you've got a Windows machine anyway, it should say C, users, and most likely your name if you're on your personal machine and it's been set up that way. If you're on a Linux or a Mac, you might see something like /home/Verena or whatever your name is. So it might look slightly different, but you should see something like this. If you haven't navigated anywhere and you've just opened your shell, you will usually by default be in what is called your home directory. So this over here is my home directory. C uses Verena, this is my home directory. So when I speak about home directory within the context of this lesson, I'm referring to this directory within users. Right. So now I want to just talk to you about how files are organized on your system. Some of this might be a bit redundant if you guys are familiar with Linux already. And so maybe this will be a bit a bit slow, but for the benefit of those that are seeing the command line for the first time, I do want to go very slow. So I hope that that's not a problem for anybody. But if I'm going too slow, please do let me know and I'll try and speed up. But I just want to quickly come to what they demonstrate on the website. They have some nice visual aids here that will help me talk through this particular portion of the lesson. So I just want to talk to you a little bit about the file structure and what we call different things. And so when I refer to these things, you are quite aware. Maybe you won't remember it immediately, but over time it will become more familiar to you. So remember that I said that we typed pwd, it returned some home directory. Remember the example of null. So if this was on null's machine or null's computer, it would have most likely returned users and null. Now you'll see that in this sort of file path, there are some things like a preceding slash, and then there are slashes in the middle that separates different files and so on. So how do we know what those things are? This is an easy way to sort of remember. This is a very simple file structure that they've demonstrated here on this page. And so you will see that this preceding slash here at the beginning of your file path is actually what we call the root directory. So the root directory is the highest level of the file structure that holds literally everything else. So it's the highest top level. So when you see this preceding slash at the beginning of a path, it's referring to this root or higher level. So from this path alone, we can see we've got from the root, we've got users, and then we've got null, and that is where null's home directory is sitting. Similarly to your machines, that is probably where your home directory is sitting. So if you transcend into the file structure, this is just obviously a fictitious file structure. You will see that inside of the root directory, we've got bin, data, users, and temp. Inside of the users file, we've then got null's home directory, because remember it says /us /users /null. So inside of users, you'll find null's home directory. Inside of null's home directory, you might find multiple other subdirectories. But this is sort of, when we talk about the file structure, this is sort of the hierarchical structures that we're talking about. And just always remember that when it's preceding a path, this always refers to root. But of course, as you can see, when it's inside of a file path, it's actually just essentially a separator. So it's just separating different file paths. Right. So you can see here with the second example, they've got users, then they've got null, but they've got two other users here, Imhotep and Larry. So this is just to demonstrate that inside of a file structure, there can be multiple home directories or multiple users. We are working within null in inverted commas home directory. So I hope that this isn't too confusing for the time being, but I hope that that's quite clear. And so I'm going to stop sharing and again, just switch back to my terminal. And now again, I'm going to do an ls, and you will see that inside of my home directory, I've got a lot of subdirectories and files and whatever else it might be that's in there. And you can see I'm in my home directory. Okay, so hopefully that part for the time being is quite clear. We're now going to move on and we're going to do a little extra commands to make our list look a little bit different. So before we've just run ls, there's something that is called an option, which makes ls behave slightly differently. And I'll talk to you about where you can find what those options are and how to use them in a second, but I'm going to ask you to just type in 1 for now and see what happens on your machine. So you're going to type in ls minus capital F. Capitalization is important. So type in ls minus F and then press enter. You will see that on my machine, the display didn't change very much. But if you had been on a Mac or Linux, this display would have changed. If you're on a Mac or a Linux, all of this would have just been monotone. It would not have had any of these characters at the end. But when you ran ls minus F, it appends these few characters at the end. And usually what that represents is the following. The / tells you that this is a directory, which may or may not contain other files. Usually the @ indicates a link. So this links to somewhere else, either on my machine or somewhere else in general. And then sometimes you would have also seen an asterisk. I don't think I've got an example of that here at the moment, but you would have also possibly seen an asterisk. I'll just type one into the terminal so you know what I'm referring to. And if you had seen an asterisk, that would have meant that that is an executable file. Right, so maybe you might see some asterisks on your terminal now when you've done your listing. I don't see any here, but it's quite useful, this ls minus F option, because it basically immediately tells you that these are folders, these are files, these are links, these are executable files, etc., etc. So it's just a different way to visualize what's on your machine. Okay, so hopefully you've all managed to do that. I'm going very slowly so that you have time to flip between the Zoom and the terminal. So hopefully you guys are managing that. Right. So now my terminal is very full at the moment. A quick shortcut to just clear your terminal is to just type clear. So if it's becoming clunky and you're getting lost and confused, every now and then just type clear, and then it will clear your terminal out for you. But now we've been working with LS, we've passed an option to it to make it do something slightly different to our list. But there are many, many options that you can pass to LS. If you want to find out what they are, you can type in ls -- help. Again, this works if you're on Git Bash. And you'll find here that there are many options that you can use. We used -f just now, right? And you can see here that it says it appends an indicator, one of these that I demonstrated to you, to entries, blah, 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 and explains it a little bit. But that's one option. But you can see that there are many, many other options that you can actually pass to the ls command. And that's going to make your list look differently. And we're going to demonstrate this in a second. So if this is not too intuitive now, don't worry. We're going to carry on and do a few demonstrations so that you understand what we mean. But if ever you're running into any trouble, you don't know how to use a command, or you don't know what the options are, it's always good practice to type in ls -- help, or it can be whatever the command is -- help, and it will pull up some help text to help guide you through how to use the command. And it also gives you the usage. So it tells you you must call the command ls, you must tell it if you want to give it an option, and then you can also pass a file or folder name, and it will operate on that. And again, we'll demonstrate that if that's not too clear. Right, so I'm just going to type clear again, slots on the terminal, and we're going to get back into it. I just quickly want to say that if you were on a Linux or a Mac, you couldn't type ls -- help. That wouldn't have worked for you. But what you can type is man ls, and that basically means bring up the manual for this command. Usually the man pages are much longer and more cumbersome. And then on the workshop website, they've given you some ways that you can navigate through that. I can't demonstrate that because I don't have a traditional Linux terminal open here. I've got the bash shell, but you're welcome to try that if you're on a Mac or Linux, and then see if you can navigate through those pages a little bit. There are some help text at the bottom usually that explains how to jump forward or move back through the pages. You can, of course, also just Google and find some help online. When in doubt, Google. It's basically my life motto these days, but Google will help you quite a lot if you get stuck as well. If you type in an option that the command line doesn't recognize or support, it will also tell you, we don't know what that is. We don't know what that option is. So we're going to type in an option that doesn't exist. So I'm going to type in ls -j, and you can actually see here it says, this is an unknown option. We don't know what this J option or flag is. And it also says try ls -- help for more information. So often the terminal will provide you with some guidance, if some is available, and tell you this is an issue, we don't recognize this, please look here for more help. Sometimes it will point out the line where an error might be in your code and so on, but it does try and help and guide you a little bit. And I also want to say, initially, you're going to make a lot of mistakes. Things are going to go wrong a lot. Don't panic, and don't take that as like a reflection of your ability. When I first started learning the command line, it took me a very long time to even just type my first command. I was very nervous. I thought I was going to break the whole system, and I had all these delusional ideas about what I would do. So don't stress too much. Usually every issue has a solution as well, but go ahead and play around, especially with just some of the commands that we're going to teach you over the next couple of days. Play around, see what things do in your file structure and your file system. Just heed some of the warnings that we're going to give you this week about certain commands that you use on your system, so that you don't accidentally, delete anything that you don't want to delete. But as a rule of thumb, play around with the shell lesson data zip folder, because, if anything goes wrong there, you can just download a fresh copy and start over. So for practice, just stick to this file structure for now. We'll go into it in a second, but just stick to that file structure. And then once you're a bit comfortable, you can work with your actual files on your machine. Right. But let's just try a couple of other things quickly. So we've done ls minus if. I'm going to show you another few options that you can pass to ls. You'll use the ls command quite a lot generally going forward, but also throughout today and tomorrow throughout this Unix lesson. So we do want you to be quite comfortable with the command and the options that you'll probably be using quite a lot. So I just want you to now type in a different option just to see what it does to the way that the files are represented visually. So we've done ls before, and it just pulls up something like this. We've done ls minus if. If you're on git bash, it's not going to return anything differently, but if you're on a Mac or Linux, it will color code things or at least append these characters. But now let's try something even different again. Let's try ls minus l, and let's see what happens. So can you all see what's happened now that I've typed in ls minus l? You're welcome to do it on your own machine as well. So what looks different now based on how we did it before and how we did it now? How much more information can you see? You don't have to understand all the outputs here yet, but can you see some differences? I'm sure you can, but I want you to interact a little bit.
Now the date and the time is included.
Exactly. So you see a lot more information, right? You actually see some of the permissions on the file. We're not going to cover that too extensively over the next couple of days, but you also see who the owner is of the files. Obviously, me, it's my file system. You can also see some information about the sizes of the files, when it was created. So it basically is a long listing format. So remember ls minus l, long listing format. So it gives you more information. But you'll see that you can couple different options. So you can say ls minus l, and I also want to say minus h, for example. So let's see what happens now. So what you would have noticed now is that actually all the file sizes became human readable. Before, you will see how the file sizes were structured. You can see over here. So not too human readable, right? But now you come down here and you see you've got things like 3.3 megabytes rather than 3 million, whatever, kilobytes or bytes or whatever it might be. So it's just made the file sizes more human readable. So you can see here, if you saw this right off the bat, that, I mean, you would understand what it is, but this is much easier, seeing it like this, 3.3 megabytes, for example. Right, so it's just made our file sizes human readable. And that's the way you can pass options to a command over and over and over and get it to do different things. I'll demonstrate just one more example. So if I had done, say, ls minus l minus t, let's see what happens now. I'm not sure if you can see what's changed here. Let's see. 20 October was the last, 0 sort of April. Right, so what it's done is it's actually sorted the output by date or by time, last time changed. So remember we added minus t, and then just quickly to demonstrate that if I do minus ls minus l minus t, this means the same thing as ls minus lt. You can even do minus ltr, however many options you want to pass, and it will do certain things to the way your output is displayed. Right. So I want you to just maybe take 1 or 2 minutes to play around with a couple of the options. So you're welcome to do ls minus minus help and see what options they give. Maybe choose 1 or 2 that we haven't demonstrated before and use it and see what happens. See if the outputs change, see if it returns an error. But basically just play around for just 2 minutes and then we will continue. So I'll give you a second. And if there are any questions or any comments at this point, we can also address them. Okay, so when you played around with the ls command a little bit and you've tried out a few of the options, just give me a thumbs up so that I can know we are good to continue. Okay, I'm seeing 1 or 2 thumbs up. Okay, perfect. So I'm going to continue for now then. I'm also guessing most of you are following along as I'm going along. So hopefully nobody is getting left behind. Just going to clear my terminal again so that we can now move on to the sort of next portion of this episode. Right. So what we've done now with the ls function is to explore our current working directory. So I just want to type in pwd again. You can see that the directory I'm in at the moment is my home directory, right? You will always be within a directory somewhere within your file structure, and we call that the current working directory. All the commands that you run will always run from within your current working directory. That might not be so intuitive to you at the moment, the way that I'm saying it, but hopefully as we demonstrate it a little bit, you'll understand what that means and the impact that it can have on the way your commands run. So this is where things might get a little bit tricky. I noticed with the last Carpentry course that I ran that Windows has done some funny things with your file systems. And so I may need to swap from explanation to explanation here a little bit, because all of you, your shell lesson data might be sitting in different places, but let's just see how it goes and then take it from there. So the first thing I want you guys to do, just so that I can see if anybody in this group is going to have this problem, is just run ls -if and then type in desktop, just like I've typed it in there. Then I want you to hit enter. If something displays, it means your desktop is located within your home directory. If you get this returned, please just type yes into the chat box for me quickly. I will need to show you where your shell lesson data is sitting when we get to that then. We're going to need to try and access that data now, actually. Okay, so I already see somebody saying yes. Okay, is there anybody else who's getting this, cannot access desktop, no such file or directory? Is it just Raymond? Okay, so perhaps it's just Raymond, but that's fine because Raymond, I would need to show you where your shell lesson data is sitting so that you can still follow along. For the rest of you, I'm guessing then you got some output, which means that your shell lesson data should be sitting there. So when you ran ls -if desktop, did one of the outputs say shell lesson data? Yes, okay, I'm seeing some people say thumbs up. Okay, perfect. So your setup is perfect. You will be able to follow things exactly as is, and there's no problem there. The rest of you might need to do something different. So Okert is saying shell lesson data / shell lesson data.zip is my return. That's perfect. That means that your shell lesson data is sitting on your desktop. So that's perfect. So you are fine as well. Okay, so I just want to show a few of you. It might not just be Raymond, maybe a few of you are shy, which is also fine. Okay, Raymond's saying, oh, it now shows the files on my desktop. Okay, sure. If it's there, then it's not a problem. If it's not there, it would have been basically located within your OneDrive, which I noticed recently. So I'm just going to show those of you who might just be following along and might discover this later, how to get there. But you will see that I don't have desktop when I do a listing here. What I do have is OneDrive. So all the new Windows machines, your desktop is actually located within your OneDrive folder. I discovered this while I was doing my last demonstration, and it was very embarrassing because I couldn't find my own shell lesson data at the time. But in case your setup is like this, I'm going to demonstrate how to use the command cd, which means change directory. But I'm just quickly going to do it now so that you know how to get there. But I will demonstrate it again once we start working with the shell lesson data. So I'm going to change directory into my OneDrive, right? When I do an ls now, you will see now I see desktop documents pictures. And now I can basically go ls -if desktop. Sorry, desktop. And you now see there is my shell lesson data. So those of you that are a bit confused or lost, just go into your OneDrive folder first. So do a change directory CD into OneDrive. And then when you run this command ls-f desktop, then you should see your shell lesson data sitting there. So the desktop has actually moved within the current Windows file structures or systems. But I think most of you have it on your desktop. So you should be able to follow now from this point. You should just be able to follow and it should be fine. Right. Another thing that I did also notice is that I have to go into my shell lesson twice. Just see where I am quickly. I am in OneDrive. Oh, sorry guys, I just need to get into my desktop first. Okay. So what I want you guys to do now is exactly what I've done here, is you want to type CD desktop to change into your desktop directory. So it will take you into your desktop folder. So just type this very quickly, CD desktop. Once you've done that, you will see that at the top of your sort of prompt, this path, you'll see that you are now in your desktop. It should show desktop at the end, right? Once you are there, you can do a quick ls to just make sure, oops, sorry, you can just do a quick ls to make sure that you see your shell lesson data. Then what I want you to do is type CD again, which means change directory. So you're moving into a file and you're going to type shell lesson data again. Just type that, right? And you're going to click enter. That executes the command, of course, as we've seen. And you'll now see that I'm in my shell lesson data. So now when I do an ls, for me, it shows shell lesson data again. Again, I mentioned that Windows file paths are buggy. So I need to do this again, but you don't. If it's on your desktop, you probably don't need to do this. But when you do an ls now, you should see exercise data and North Pacific Gyre. So once you're in your shell lesson data folder, if you do an ls, you should see exercise data and North Pacific Gyre. Remember Null's example? She was collecting data for the North Pacific Gyre. So clearly we're going to come back to this folder in a bit. But you should see this, exercise data, North Pacific Gyre. If you've all gotten that far, please just give me a thumbs up. Okay, seeing quite a few thumbs up, so I'm quite confident everybody's following along. Okay, perfect. So you all see exercise data and you see North Pacific Gyre. Fantastic. Right, so now I want you to try something just to demonstrate. You know, earlier I said that when you run a command, it runs from within your current working directory, right? So you are, if you type pwd, it will give you the full path to your current directory, but you are in shell lesson data, right? All of us should be in shell lesson data now. Now I want you to do something, which is type in change directory, shell lesson data again, right? We're not doing anything different to what we've done before, but when you hit enter now, it's saying shell lesson data, no such file or directory, but it does exist. So why do you think that it's returning no such file or directory? Any guesses for why that might be happening?
There isn't such a file or directory inside our current working directory, right? It's not available.
Awesome. Yeah, 100%. So if we do an ls, remember we said that when you run commands, it's within your current working directory. So if I run ls, what is within our current working directory? It's exercise data and North Pacific Gyre. So when we write cd shell lesson data, it's looking for this directory within this directory. It doesn't exist there, right? So that is 100% correct, Sine. Thank you for that answer. It's nice to see that you also got that conceptually. So that is a very sort of conceptual thing that you need to keep in mind all the time. Sometimes when you run commands, you'll be banging your head against the wall thinking, why is this not running? Why is this not running? It's because you haven't specified actually your file path properly, or it's running from within a working directory, but you want to point to a different working directory, and so on and so on. There are ways to do that, but if you just run commands this way, it's always going to look for your file that you want to operate on from within your current working directory. If it doesn't exist there, it will return error. So just keep that in mind going forward. I must say this did stump me every now and then, but it's also normal if that does happen, so no stress. Right. So what happens if we do want to move back one directory? There's a little shortcut for that I will show you now. So let's say we want to move back to our main directory. For me, it's still going to be shell lesson data. For you, you're going to move one directory up. So it's probably going to be desktop. But if you had done cd and then type ... So you can try this now, cd, that's change directory space ... You click enter. And you see now how this file path has changed. It shifted me one level up. So this is a nice shortcut for when you want to run something from what we call the parent folder. So for me, my parent folder is also shell lesson data because of the funky stuff that Windows has done. But for you, your parent folder now is going to probably be desktop. So you'll currently be in your desktop folder at the moment. And inside of your desktop folder will obviously be the shell lesson data and whatever else is sitting on your desktop. But this is a nice way to just move one level up. So if you ever just need to move one level up, you type cd ... There are other ways to move multiple levels up and so on. We're not going to cover that right now. But you can see if I type pwd now, it's changed from shell lesson data to just shell lesson data. For you, it's going to be desktop again now, hopefully. But for me, because like I said, things are a bit funky, I've got some extra file paths here. But hopefully it's not confusing you. I really hope it's not. But now we're back to the shell lesson data, right? So now if I do an ls, I see shell lesson data. You also actually should see shell lesson data, right? Now I want you to just change directory back into your shell lesson data. And when you do an ls, you should see exercise data and North Pacific Gyre again, right? So you should be back within your shell lesson data now. And now I want you to do something slightly different, which is to pass two different options that maybe you have or haven't used before when you were playing around. But you're going to pass the option -f, capital F, and -a, small letter a. Right. Then you're going to hit enter. Now you see exercise data, North Pacific Gyre, but you also see this dot and this double dot, right? So this double dot represents your parent directory from this current directory. So it represents one level up. So it basically just means the file that contains these two files. In layman's terms. So when I type change directory ... it knows that it's actually going to this file, right? Or this level. But then you also see this singular dot. This singular dot means current working directory. Now this might seem redundant, but again, we're going to have some examples of when that actually becomes important. So whenever you see some script in a command line and it says change directory and it's got some stuff and it's got dot. That dot means current working directory. I just want you to understand what it is for now. We're going to demonstrate how to use it in just a second. But what this -a flag here basically does is just it tells this list command show everything that is in the folder, including hidden files or hidden directories. And so these two directories are usually hidden. So usually when you would do ls, you wouldn't see them. But adding the -a flag means show me everything, including hidden files, and then you see them over there. So these are actually part of the file system and structure. just in case you're wondering, poof, where did these dots come from? That is kind of how you can understand it. Right. So now let's just quickly, oops, sorry, I'm just getting all these emails coming through. I just want to shut down my email very quickly so that you don't get these annoying pings the whole time. Sorry about that, guys. Hopefully it will be a bit better now. But okay, I think before we continue, let me show you a couple of other just sort of navigation tips and tricks, or just a couple of shortcuts that might be useful to you. It might be a bit confusing now if you're seeing a lot of this for the first time. So if it is, don't worry. It's just so that if you also use it in the scripts going forward, you have more or less of an idea of what it does, but we will talk you through what all of these things mean as we go along anyway. Right, so I'm going to ask you now to just quickly change directory into exercise data. The first thing I'm going to show you is tab completion. So you can type EXE and then press tab. So the tab button on your keyboard, and you will see that actually the rest of the file name has auto-completed. In the same way, I could have typed in NOR, press tab, and you see it's completed North Pacific Gyre for me. So tab completion is very useful. It limits spelling and human errors, especially when file names are complex. Usually you have to just pass at least 3 letters to the shell. And when you hit tab, it will auto-complete if nothing else, of course, matches these 3 letters. So it must be unique in some way. So if you had North Pacific Gyre, North something else Gyre, if you wanted to get to North Pacific Gyre, you might have needed to enter a few more characters so that it matches the right thing. But tab completion generally is quite useful. Another thing that I'd like to show you is that if I just press the up arrow, you will see that it's showing me the command that I ran just before. And if I press up again, it's showing the command ran before that. And if I press up again, it's showing the command run before that. And then if I press down, it's showing the command run after this command, and so on and so on. So this again is a useful way for you to not have to retype certain things. So maybe there was a small error in your script, something went wrong. You actually wanted to type it like that. Then it helps you do that, and then you can hit enter. And then you can just rerun the same command. So for rerunning commands, that's quite nice. Right. So now what I want you to do is type in CD and type in EXE, tab complete, and press enter. Now type in PWD. You'll see that you are now in your exercise data folder. Right. So what happens if from here, you want to maybe just quickly go back to the previous folder that you were in? You can type CD dash, and this you can think of as like an alt key, alternate between 2 views. If I type in CD dash, it takes me back to shell lesson data out of exercise data. If I type in CD dash again, it takes me back to exercise data. Maybe this is better to demonstrate a different way. So let me just type in just CD. And whenever you type in just CD, it actually takes you back to your home directory, always, almost always. So if you just type in CD and you don't type in anything else and you hit enter, you will see I'm now back in my home directory. Now if I use CD dash, which remember is that almost like an alt button or an alt key, and I click enter, hey, I'm back in exercise data. So this is a nice way to flip between different folders. So maybe you've navigated somewhere and actually you want to just quickly go back to where you were. You wouldn't have to type in the full path again. You can just use CD dash and you can switch between 2 sort of folders, at least in this example. One other shortcut that I can show you is the tilde. So whenever you're seeing scripts, you might see this tilde a lot, and you might see something like tilde, desktop, folders. What this tilde represents is your home directory. So my home directory, if I can just go back to, back to my home directory quickly, pwd, my home directory is C users Verena, right? So like I said, the tilde can stand in place of your home directory. So if I had wanted to navigate, let me just maybe copy across this. If I had maybe wanted to navigate here, just as an example, just want to copy that. Why is that not working? Just give me a second. Okay, so let's say I had wanted to navigate here, but I didn't want to type in my home information, which is usually not a lot to type anyway. But again, it just, makes your life a little bit easier. I could have replaced that home bit, this bit, with a tilde, and it would have done exactly the same thing as if it wasn't there. See, so it's saying this is a directory, but I could have typed in, maybe I should have typed in change directory. It's just saying it is a directory and it exists. So I just put the file path there. I didn't put any command, so it didn't do anything. It just said this is a directory. But if I had said change directory, it would have taken me straight into that directory. And you'll see the full path still has this home and the rest of the file path. Right. So those are a couple of shortcuts. I went through them a little bit quickly now. So if you want to practice a little bit, please do go ahead. I'm going to give you just maybe a few minutes to just maybe play around with some of those commands a little bit. What I'll also do is let me just maybe pull it up on the screen for you so that you can just try a few of them just, for practice before we move on to the next bit. It is tied to an exercise, so you can actually do the whole exercise if you like, but at the very least, I just want you to play around with some of the change directory shortcuts and commands. So I'm quickly going to just share the workshop website again. So this is the navigating files and folders or files and directories. On this page, there is this example, so you can actually work through the example, or you can just play around with some of these functions and see what happens. Try the CD dash, try the CD dot or the CD dot dot. Think about what might happen if you typed in CD dot dot / dot dot, CD tilde. So try a few of those things on your command line and see what happens, see what it does to your files or your structure. And then we'll move on to the next bit of this portion of the lesson, and then we'll basically take a break at the end of this episode. So not too much more to do before we take a quick break, but play around. Okay, so once you've played around with some of those a little bit, again, just give me a thumbs up. And then let me know that it's okay for us to continue. Yeah, I've seen one thumbs up. Okay, another thumbs up. Okay. I think let's continue for now. So I know this might be a lot of information to take in. So if it is a bit overwhelming, like I said, please try not to stress. We're trying to step you through a lot of the commands very, very slowly. I know maybe you won't remember everything, but for example, if from the previous lesson you remember LS, and that it has some options, and you remember CD, and then that allows you to change through your folder structure or move through your folder structure, then I'd be happy. If at the very least you remember that. So when you see CD in some code somewhere, sometime, you know exactly what's going to be happening with that code, what you're going to be doing. One thing we haven't discussed too much is absolute versus relative paths. We have been speaking about it sort of haphazardly, but we haven't really defined what is the difference between an absolute and a relative path. And so I thought we could maybe do this little example together now. I know that you guys have played around with some of these commands just a little bit now, but I want us to just step through maybe just one example. I don't think we've got time for a lot. So let's maybe do the second example. I think this will help you understand relative versus absolute paths a little bit better. But before I get to the example, let me just sort of give you a very brief explanation of what a relative versus an absolute path is. Sorry, I'm getting tongue-tied the whole time. So remember that I said that when you run a command, it runs from within your current working directory. When we've been navigating around now, we've always navigated basically relative to where we were before. So we went into a folder, then changed directory into another folder, then changed directory into another folder, right? So that is relative paths because it's relative to where we started. But you do also have this thing called an absolute path. So when in the command line, you give the whole path to a file or to a folder, like they've demonstrated here, all the way from your home directory, navigating through your file structure to the file that you want, we call that an absolute path. And it would almost always start with either the tilde, which represents home, or the preceding slash, which would mean root. So, you know, like here, transcend from root, going to users, going to Amanda, going to data, then go into XYZ. So it tells you from root or from your home where you need to go step by step. That is what we call an absolute path. Whereas the relative path, for example, like I said, is relative to from where you are now. So when we were in shell lesson data, for example, we then said change directory to exercise data. We said change directory to get back to our own directory, but it was always from basically within the shell lesson data. So that was a relative movement. I hope that this isn't too confusing. You guys are all mostly physics people, so I think conceptually you guys should be fine. And I don't want to repeat it over and over if I'm just being redundant. So can you just give me a thumbs up if you're understanding that? Or just let me know if you want me to explain it a little bit more. Or maybe clarify, use different language. I can try and do that. But okay, I'm seeing a few thumbs up, so I think that that's okay for now. And maybe once we demonstrate with an example, it would be much more clear too. So let's do this example. I was going to say do it maybe individually, but I think let's step through this example as a group. Some of the future examples you can try on your own and then feedback. But let's step through this one as a group because I think this is very, very important just in terms of your conceptual understanding of how the commands are working. Right. So for this particular example, they are saying using the file system diagram below, that's this diagram, if PWD, that is print working directory, displays users /thing. So it's saying when you print your working directory, it's saying users /thing. So this is where you are. It's now asking what will ls minus f ... /backup display. Which of these options are correct? Right, now let's step through this piece by piece. Will it display ... backup no such file or directory? Will it display some dates, which is these files here at the bottom? So is it going to return those files? Is it going to return those files as folders? Is it going to be here? Is it going to return these set of folders? So let's take it step by step. We firstly are told that we are inside users /thing. So this is where we currently are. Now remember, that when you're running commands, it's running from within your current working directory. So within this example, this is the current working directory thing. It's now saying if you run the command ls -if, so -if doesn't do anything but append some characters at the end, right, to tell you whether it's a file or it's a link or it's an executable. But it's telling you when you run ls -if, and then it says ... /backup. So what does that ... mean? It means you move one level up, right? So although you're operating from within this folder, it's telling you when you run the command must be run on this file or folder. It's telling you move one step up, which is now back in users. And then it's telling you /backup. So now you're here. So when you are running ls -if, although you're located in thing, you have said or specified a relative path to backup based on where you are now. Right, so you said, or the example is saying, move up one directory, remember, ... means up one directory, your parent directory from where you are now, so one up. And then it says /backup, so you've moved into backup. So when you run ls -if ... /backup, what are you seeing? Based on these 4 options, what do you think is going to be your output?
It's gonna be the original and that like thing.
Option 4. Yeah. So that is perfect, 100% correct. It will return option 4, original, PNAS final, PNAS sub. Does everybody on the call understand why that is? If you don't understand, no problem. Let us know, and then we can step through it another time, and hopefully we can try and figure out where you're getting lost. Does everybody understand why it's returning option 4? Just give me a thumbs up if you're good and you understand, or a thumbs down if you don't. Okay, seeing a couple of thumbs up. Don't see any thumbs down, so I'm going to assume that you're okay. At any point during the lesson, you can also just give me a thumbs down, and then I know, hey, you're stuck, you're not really understanding, and we can circle back. Also, if you're stuck at any point, please let us know via the chat box. What we can possibly do, I'm not sure if we can do this, Nikita, but I think we can open a breakout room, and maybe you can shift there with Nikita, for example, and maybe she can help catch you up a little bit, or address some of your issues, and then you can move back to the main room. But at no point do we want anybody to be lost, and we work through the content extremely slowly, so that we prevent you getting lost. But it seems like everybody's on track. But I just want to do these check-ins every now and then, just to remind everybody, you know, no question is a silly question. If you need an answer, we are happy to provide it. Right. Okay, so that's the sort of relative versus absolute path example that I wanted to cover. There's not much else that we need to do for this episode before we take a quick break. But there are just a couple of things that I also just want to talk you through. It might already be quite intuitive because you've been working with it now, but just by ways of having formally explained it, let's just go through the general syntax of a shell command. Now, this is probably going to be quite familiar now because we've worked with these commands now quite a lot throughout this lesson. But just to give you an idea of the general structure of a command, it always starts with a prompt. The prompt, of course, doesn't look the same on all terminals, but there will always be a prompt. And at the prompt is where you will be able to start typing your commands. And the shell will then interpret it and then do what you've asked it to do. You always start by specifying the command. Almost always, you'll specify your command. This is NB, you have to do this. Your command may or may not take an option. Some people refer to options as switches or flags. And so if you hear somebody talk about a switch or a flag in the context of the command line, they usually are talking about these options. So these options that make the command do things slightly differently. So it specifies how it wants the command to run over a particular set of files or folders. But this option is not compulsory. As you've seen with our demonstrations, we've typed in ls and it just ran on our current working directory. We've typed in ls -f, ls -l, all of them work. So most commands you can actually run without specifying options and arguments. I'll come back to the argument in a second. But all commands obviously need a command. You need to start by specifying the command, but either the option or the argument can be missing. It depends. So when you talk about an argument, this is basically what you want the command to act on. So for the purposes of these demonstrations and for the purposes of our discussions, this argument has always been a file or a directory so far. And for the most part, it's always going to be a file or directory within the context of this lesson. So just remember that typically you're specifying a command, you're passing an option which tells the command what to do or how to act and how to output things. And then that is usually enacted on a file or a folder or something, right? So you have the command, how you want the command to run and what you want the command to run on. This is the general sort of syntax of the shell. And I think you've all explored that a little bit now. You've worked with it a little bit. So I think that is quite intuitive and quite clear. I think for now we can stop there. I don't think anything else over here is that pertinent. And I've actually touched on really quite most of it as we've progressed with the lesson. If you come back to today's schedule, you'll see that actually at 10 o'clock we were scheduled to have a short break. And we'll then come back at 10:30, where we'll continue with working with files and folders. So here we're going to start making some directories, making some files, and really interacting with our file structure in a much more intimate way, if I can put it like that. Yeah, so we're going to take a quick break. Let's take about 23 minutes, which would bring us back at about 10:30, if that's okay with everyone. I'm going to just set a little Kaku timer. Let's set it for 25 minutes. Once this timer goes off, we'll be back. So let's have a break. Thanks, Nikita. So I'll just quickly share my screen again, just to show you sort of where we are with the lesson. So there are only two more portions of the lesson that we'd like to get through at least today, and that is the working with files and directories and the pipes and filters. Once we get to the end of the pipes and filters, if we have a little bit of time, we can go on to loops. But perhaps we keep that for tomorrow, because by the end of pipes and filters, there would have been a lot of new things that you would have learned at that point. And so maybe you'll want to digest that a little bit before coming back and learning a little bit more. So I'll do a quick check-in after the pipes and filters to see how everyone's feeling, and then we can take it from there. Right. So we're moving on now to working with files and directories, and I will pull up my terminal in just a second. But just to give you an idea of what you'll cover with this portion of the lesson. So we'll basically be looking at things like creating files and directories, copying or deleting files and directories, and then basically having the ability to create specific folder structures if you need to do that, and how you would go about that, and so on and so on. We won't go into any like great depths, but we'll once again just be giving you some foundational commands and things to get you started. So I'm going to quickly just switch back to my terminal. So hopefully you can all see my terminal. So earlier, we were working inside of our exercise data subdirectory. We weren't really doing much there, but we just navigated to exercise data. So what I want you guys to do now is once again navigate to this file. If you've at some point navigated out of it or switched to a different folder, just get back to exercise data. So for most of you, you're going to be able to do a change directory desktop first. So you can do that. Once you've changed directory desktop, you will change into your shell lesson data. Once inside of your shell lesson data, you should see your exercise data, and you can also type it in exactly like I'm typing it in now and just go straight there. You click enter now if you've typed it in just like I've got it here, and it should take you straight there. But as you know, my file path is slightly different. And so I have to do things a little bit differently to get to the exercise data. But what I'll do is I'll also start from the beginning so that you can see me navigate there as well. Right. So it's OneDrive. Inside of my OneDrive, I've got my desktop. Inside of my desktop, I've got my shell lesson data. And then for me, of course, I need to transcend twice down shell lesson data. And then when I do that, I'm in my shell lesson data. So now I can just change directly into my exercise data. Right. Okay, now just get a show of hands again, just by means of a thumbs up to see if everyone's inside exercise data. When you do an LS, do you see this returned? So it's 4 folders and 1 text file. Do you see that? Yes. Okay. See 1 thumbs up. Okay, a few more now. Okay, perfect. I'll just give everybody else just a couple of seconds to get there. So just to remind you, exercise data is where we should be. And we'll start within that folder now for this portion of the lesson. Right. So you'll see that within this exercise data, there's this writing folder. I want you to just go into that folder. So change directory writing. And just remember, try and use your tab completion as often as possible to limit spelling errors. That just makes things a lot easier. Once you're in writing, just do another LS for me. You should see 2 files, the little woman.txt and the haiku.txt. Hopefully you all see that. We're now going to, within this writing folder, create a new directory. So I want to just be sure we are all in the right place. We're all in exercise data, and we've now gone into the writing folder. Okay, now we're going to learn a new command, which is mkdir. It literally also stands for basically make a directory. So make or create a new directory. So we're going to create a directory called thesis. Remember, Nell has to write the thesis, and so we must create a space for her to write her thesis. And the make directory command, like always, will run within your current working directory, which is within the writing. So type this in, mkdir thesis, and then you're just gonna hit enter. You'll see nothing is returned to the screen, but when you do an ls now, you see the extra directory here now called thesis. Remember when we did an ls before, it just said little woman and haiku.txt. Now we have that, plus our directory that we made with mkdir called thesis. Right. Again, thumbs up if you've managed to create your thesis directory now. Yes, yes, awesome. Awesome stuff. Right, so there you've just made a new folder with the command line, simple as that. Now, if we do an ls -f, for those of you that are on a Mac with thesis, you'll probably see nothing returned. We didn't put anything in the thesis directory, we just created an empty folder, an empty directory, same way as on Windows, you would click, right-click and go make a new folder or new folder. We did that basically with the command line. But now we made one folder this time, right? Just one directory. You can also pass an option. Remember, we were passing options to ls before. Make directory also has options, and it's got this one option called -p. What this allows you to do is to actually create a directory with a couple of subdirectories inside of it all at once. It's a little bit more complex how you would do this. So the example that the carpentries give is to move up one level. So remember, we are in writing. So it's telling us move up one level. So we're moving into exercise data again. And we're going to make a directory called project. So we're actually making a new directory now. And within the project directory, there'll be a subdirectory data. But now we don't just want the subdirectory data, we also want the subdirectory called results, and maybe we want a few others. So you can actually go on specifying how many subdirectories you want. You just have to always specify the parent directory like we have here. So it's going within the same parent directory, and it will have these two subdirectories, data and results. We aren't adding any extensions, so we are just literally making some more directories. So now when I hit enter, remember it ran from inside my current working directory. So if I do an ls here, you don't see project, you only see thesis, right? But if I did change directory ... remember moving up one level, and I do an ls now, you now see, hey, I've got the directory project now. And if I do an ls on project, oops, sorry. If I do an ls on project, you'll see that we've got data and results as subdirectories within project. Quite cool, right? Seems very convoluted and complex, but actually you're doing very, very simple things. Over time, you'll learn to string commands together in much better ways. But in the beginning, your code might look a little bit like this. You know, you're stepping through things step by step, maybe a bit clunky. And over time, as you learn more shortcuts, it'll become, you know, cleaner and cleaner, and it will probably start looking like more and more gibberish also over time. But okay, cool. Let's get back quickly into our writing folder where we were before. Okay, just making sure we're in the right place. You could also have checked from within the current folder. Remember, we ran this, the make directory -p to make the project directory, and then the data and results subdirectories. We ran that from within the writing directory. So you could have also checked that that directory was sorry, properly created and what was in there from within the current directory. So you could have done like a -f space ... Remember, we created it one directory up, and then you could have completed project. And there we go. Directory was created and it contains data and results. Okay, so hopefully you have all managed to do that now. I'm going to just touch on very briefly, and I won't speak to it any great length, but I'll just touch on it very briefly on just file naming conventions. So with the command line, how you name and label your files is extremely important. You can see that certain characters on the command line mean certain things. And so if those characters exist within your file names, you could have a lot of problems. If your file names have spaces and weird dashes or whatever it might be, sometimes the way you specify those files can also change, adding another element of, you know, potential human error. So it's good practice to just name your files correctly from the get-go. So just a couple of best practices for naming files, especially when you're working on the command line. Don't use spaces. So project space A is bad. That space means something on the command line, right? It will read project and a space, and it might expect something else, not the A. It won't understand what the A is, for example. Writing it as project underscore A would be better, but writing it as project underscore small a would be even better, because capitalization also matters on the command line. Whether a letter is capitalized or not, it does matter, and it will affect how things run and what it does. Of course, also, using underscores is much better than using dashes generally, but you can use a dash within a file name. That's not too bad. but try to stick with, you know, the regular convention. So use a dash or a full stop or an underscore and a full stop in your file names. Try to stay away from other characters. So try not to use fancy characters like stars or question marks or ampersands, nothing like that, because that all means something on the command line. So just be very careful of that. I'm not going to say too much more about that. I'm just going to leave it at that for now. Just think about how you name your files and how it might affect things running on the command line when, you know, a space and a dot and a space means something different on the command line. Okay, so having said that, let's just do a quick PWD to see where we are. Okay, we're still in exercise data writing. Let's do a quick ls to remind ourselves of what's here. We've got the little woman.txt, haiku.txt, and thesis. We now want you to change into your thesis directory. So do cd, change directory, thesis, and enter. If you do an ls, it will return nothing because thesis is an empty directory. There's nothing in there. So let's now put something in there. Now, when you downloaded Git Bash, hopefully, it would have downloaded Nano. It's a text editor. So you can create a file using Nano, the text editor. So let's create a file called nano draft.txt. Right? So I'll leave that there for a second so you can type it in, nano space draft.txt. Then you're going to click enter and something's going to happen. Voila. The nano text opener or text editor opens, and you can begin entering text. You can enter whatever else it accepts there, just text basically. So we're going to type something in there and then we're going to save it. So you're actually creating a text file now. So there's not much we want you to type, but just a very simple little sentence. So we want you to type, it's not publish or perish anymore, comma, it's share, and thrive. Right, so you're going to type that little sentence out for me in the text editor. I'm going to leave it up for a few seconds so you can get that typed out. So just, it's not publish or perish anymore. It's share and thrive. Right. So once you've typed that in order to save the file, you're going to type Control or Command on your keyboard and then O. You see here it says Control O write out. That is to save the file. So I'm going to do that now. Control O. There it says file name to write draft.txt. Yes, because we gave it draft.txt, and I'm just going to hit enter. And you'll see it returns wrote 2 lines. So it wrote those 2 lines into the file. We can now Control X, you see here, to exit this nano editor. So just type Control X and it will bring you back into the shell. And now if you do an ls, you'll see draft.txt now exists within your thesis directory. Okay. Has everyone been able to do that? Just give me a thumbs up if yes. Okay, I see a couple of thumbs up, but let me give you a second for those who might still be busy. And I'm also just keeping an eye on the chat box. So to exit Nano, you're going to type Control. You just type it into the chat box plus X on your keyboard. So your Control button and X will help you exit. But if you want to save, you're going to hit Control plus O, the letter O on your machine. Either Control or Command, depending on what OS you're using. Okay, but it seems like everybody's more or less been able to do that now, yes? Is anybody still busy with that? Okay, I'm not seeing anybody indicate that they're still busy. I'm struggling to exit. Okay. So Yandile, what do you, if you're comfortable unmuting, what do you see on your screen at the moment? Is Nano open at the moment?
Yes, Nano is still open.
Okay, and are you on a Windows system, a Mac, a Linux?
I'm on Windows.
On Windows, okay. So is it allowing you to Control X and then it will ask you if you'd like to exit?
No, when I pressed Control O, it said file name to write, and then the colon draft.txt. But then
Yes,
after
then
that, when I try pressing Control X, it gives me nothing, just that sound.
okay, so I think what you needed to do was when it showed draft.txt, you needed to press enter first. And then you would be able to Control X. So you just needed to press enter to save to that file name first. But what is it showing you at the moment? Is it just a blank screen or what?
Hold on.
Would you
Okay, I
like
know
to
it's
share your
okay.
screen by?
It's okay.
Sorry?
I'm out. I'm
Okay,
fine
okay,
now.
sure.
Thanks.
No problem, no problem. Okay, sure. Yeah, sometimes these text editors take a bit of time to get used to. I also just want to say that Nano is a very, very simple text editor. You get complex text editors that you can use with the shell. So when you work with the command line a little bit more going forward, you might hear a lot of people refer to Vim, for example. Vim is quite a popular text editor, but it requires a lot more time to learn and sort of wrap your head around how to navigate it and use it and so on. But just to say that we are using Nano right now, it's very simple. It can't do anything complex, but others do exist. So going forward, if you need something more complex, you can always install it, and then you will be able to use it. But in some cases, there are some text editors that are native when you install your shell or Ubuntu or Linux or whatever it might be. There might be some text editors that are just native, that are just there. Like when we installed Kitbash, Nano was one of the text editors that it just automatically installs us. I think there was somewhere where you might have needed to click yes or no, but it is most of the time the text editor that it automatically installs. But yeah, it does take a bit of time sometimes here and there to get used to it. But hopefully everybody's been able to do this now and you've got your draft.txt file. Okay. You can also create a file a different way. So one thing you would have noticed is when we did nano draft.txt, when the nano text editor opened, it expected us to input some information, right? But once you start programming and coding a little bit more, or maybe you already are, and so you would understand this example, you may need to, for example, push output to an empty file. But that empty file within your system might not exist. And so you might need to create that empty file as part of your code or your script, right? So there's something called touch. It's another command. It's literally written the way you write the word touch. So you could have done touch, and let's create a different file now. So I'll just call it myfile.txt to follow what the Carpentry suggests. And when you press enter now, you'll see that no text editor pops up. But if you do an ls, the file was created. And now if you do an ls -l, for example, you can see that it's an empty file. It's got 0 bytes, it's got nothing in there, it's just a file. Whereas here we've entered some text, and so you can see here the file size is slightly larger, but very useful for when you need to create empty files that you need to push, for example, outputs from your scripts to, or maybe you have some logs or whatever that need to push to a specific location, and that location needs to be created within the script. This becomes quite useful. It might not seem too useful right now, but once you start scripting a little bit more, it will become a lot more clear why something like this is actually quite useful. But that's just to show you that kind of flexibility does exist with the command line. Now, what we want to also show you is that you can also remove files. So you can remove files by literally using the command called rm. So let's remove the myfile.txt that we just created. right? So I'm just going to type in RM and then the file name, hit enter. And then when I do an ls, you see that the file has actually been deleted now. One thing you must be careful about is deleting things on the command line. I know that there are some systems now that are starting to have some trash boxes and things, but for the most part, when you delete something with the command line, it is usually gone forever. So you have to be very careful, but we'll show you some tricks for how to prevent you deleting anything that you don't want to have deleted in just a second. We'll come back to that once we start deleting some of the directories that we're creating. But for now, we just want to go back to the writing directory, and we're going to start to show you how to rename a few things and move a few things around. So let's go back to writing. So most of us should be in thesis right now. This is where we currently are. We want to move one level up to writing. So all of us can type cd ... click enter, do a quick pwd, and you should be back in the writing subdirectory. Right, I'll give you a couple of seconds to do that. You're just going to move back to the writing subdirectory. Now let's do a quick ls, remind ourselves of what's within our writing subdirectory, our two files, and our new directory thesis that we've created. Right. So now we're going to show you a little command called mv. And we're going to look at what it does with a little example quickly. And you can follow along here, or you can try it afterwards. But we are going to say, take the draft.txt file that exists within our thesis folder and basically rename it to quotes.txt. So let's see what this command does and if it actually does what we think it's going to do. So just to remind you that inside of thesis right now exists draft.txt. It's the only file that exists there because we removed the myfile.txt, so nothing else is in there right now. And we're using the move or the mv function to do something to draft.txt. So let's see what happens, and then we'll chat about it. So now if I do an ls on thesis, you now see that draft.txt doesn't exist within this file folder anymore. It's only quotes.txt. So what the mv function does is essentially renames a file. Well, you can use it to rename a file. It's got more functions than that. But this is a function that's command that's commonly used to rename files. But you also, again, have to be very, very careful, because if quotes.txt did exist already, it would have just overwritten it and made a new quotes.txt file. So again, with the command line, you have to be very careful with what you do and very deliberate so that you don't delete things by accident or overwrite things by accident. But this was a way for us to rename our files now. So we are in the writing file. Our quotes.txt file exists within the thesis folder that sits within the writing. Remember before I mentioned that if we do an ls -a, you see these two subdirectories, which means parent and current. And we haven't really touched on how to use the current working directory quite often. But again, this is a relative path, not an absolute path. So let me demonstrate what might happen if we do use it. So the move command can also be used to move files and directories, as well as rewrite their names. So we just have to be very careful with how we use it and just understand the syntax of it. But I'll show you what happens now. If I say move thesis, and we've got our file, which is called quotes.txt, and I just put a dot there. So the dot, remember, represents our current working directory. So our current working directory is writing. So I'm saying move the quotes.txt file from inside the thesis folder, move that file to my current working directory. And this might seem silly, But again, as we move along, you'll understand why having something that points to a current working directory is quite useful. So if I pressed enter now, and I now did an ls within my writing working directory, you now see that the file has shifted. It's removed it from thesis, and it shifted it into the current working directory, which is writing. So with this process, what we've done now is we created the file firstly called draft.txt. We used the mv function to rename that file to quotes.txt. We then moved the quotes.txt file out of thesis and into the writing subdirectory for the first time using the current working directory sort of shortcut. So hopefully you've all managed to follow along with that. If you were following me first and now want to try it on your own, then take a minute or so to do that. And then after that, we'll move on. Yandile, go ahead.
Yes, I wanted to ask about the MV command. When you, if
Yep.
we're already in the let's say the thesis directory, do we need to write it? Do we need to indicate that it's under thesis?
Do you mean where we wrote it like this?
Yeah, something like that. Do we, if we're already inside the thesis directory, do we still have to indicate it?
No. But remember, we weren't in the thesis directory when we did type this. We were in the writing directory. So that's why we specify thesis and then the file, because remember we're giving the path from where we are. So we are in writing, so we have to say thesis / quotes.txt because we're giving the path to the files. So that's why we did it. But if we were inside of thesis already, then we could have just did mv draft.txt to quotes.txt. Then you didn't need this portion where we have the thesis and the slash.
Okay, thank you.
If you were already inside thesis and you wanted to move your quotes into writing, which is what we did with our command, right? Then you would have double dot, right, to say move it up. You would take move quotes.txt double dot to put it up in writing because we're not currently in writing. Am I right?
Yes, yeah.
Okay.
100%.
But in our case, we were already in writing, so we said move it here with the dot.
Yeah,
the single dot.
exactly.
Okay.
Exactly.
Cool.
Yeah, so I mean, at the moment, all we're doing is obviously working with some files and folders. But as we progress with the lesson, we'll do a few more things where we actually loop over some files and so on. But at the moment, I think everybody's conceptual understanding is there, so I'm quite happy about that actually. So I think it's okay if we continue on from here. But another thing I want to say is this is just an example data file, right? If you remove things accidentally or you delete things accidentally, nobody's going to die. So please go ahead and play around. So if you want to try, some of the commands and functions in different ways with some different files, go ahead. Nothing bad is going to happen. If you mess up the file and you need to re-download or re-unzip the shell lesson data, that's fine. You can always recover what you've done. So play around with things. If you want to see what might happen if you did things within the file, etc., do that. That's not a problem. Like I said, if something goes wrong with your file structure, you can just re-download that copy of the file or just re-unzip it. If you've got the zip file still, just re-unzip it again, and then you have all your files back. So yeah, so play around and see what happens, and make the mistakes on the example data. Rather don't make those mistakes on your own data. So play around, make some mistakes, and ask for help if you need to fix it. Okay. For now, let's carry on. So I just want to show you very quickly a few other things. So there's an example, a little exercise that they kind of give that maybe we can do, because it might also give you a bit of an understanding of how the move command works. And then after that, we can shift over to talking about copying files and directories. So I'm going to stop sharing quickly and just share the actual site again. Just want to show you the exercise that they give. Just find the right one. Okay, it's this one. So what I want us to do is to just maybe take 5 minutes to work on this. And then I would like one of you on the call to report back on what you think the solution is. Please don't look at the solution on the page. First try. And even if you do it incorrectly, let's talk through why it's incorrect, because you know that's much richer in terms of our learning anyway. So look at the question. I'm going to just go through it very quickly, and then I'll just start the timer for 5 minutes. We'll come back and we'll look at the solution, and then we'll carry on. So the example that they give, again, it's on the working with files and directories. Remember, we sent you the link to the main page. So if you click on working with files and directories, it'll bring you here. You can just scroll down to where you see this example, moving files to a new folder. So this is a conceptual example. This isn't something you have to do. But if you want to create all the files first, then I guess you can do that, but I don't think we have time for that. But essentially, they give you this example of after running the following commands, Jamie realizes that she put the files sucrose.dat and maltose.dat into the wrong folder. The file should have been placed into the raw folder. Right. So the commands she ran are the following: ls -if, and she got back that there's two files, or two folders, sorry, analyzed and raw. She then did an ls -if analyzed, and she saw that fructose, glucose, maltose, and sucrose are in the analyzed folder. But remember, what she wanted to do was put the sucrose and the maltose into the raw folder. She has now typed change directory analyzed. So where she is inside of the analyzed folder. So now think about what she would have to do. So basically complete the blank spots here. They've already given you a hint of what you need to do. You need to start with MV because you're moving files, and you're moving sucrose.dat and maltose.dat. Those are the two files you're moving from within the analyzed folder. So basically just complete the path here and let us know how you would move sucrose.dat and maltose.dat into the raw folder, which is on the same level as the analyzed folder. Okay, so just take a few minutes to think about that, and then let us know what the answer is. Either you can type it on the chat box, or you can raise your hand when you have an answer for us. So let's not take more than 5 minutes, but if you have an answer, like I said, put it on the chat box, or just quickly raise your hand and let us know what it is and how you got there. Oh, we've got one already. Oh, you guys are quick, eh? Yandile, you also raised your hand. So
What's
it
a
is,
question?
sorry, go ahead.
I wanted to ask a question. Can in
Yeah.
between those, can you use those double dots? Is it possible to use those double dots, but like in with a what's this? Where it's underlined, where there's
Yes.
something floating.
Yes, that is exactly right. Because remember, you're in the analyzed folder at the moment, and you want to move one level up in order to see the raw folder, because you're moving it to the raw folder. So now I see the solution is already on the chat, so I'm going to open it up here. And what you've described now is exactly right. So you would say move these files into the raw folder. So you're going to go up one level, because remember, analyzed and raw is on the same level, and you've changed directly into the analyzed folder. So in order to be able to move to the raw folder, or basically see the raw folder, you would have to move one level up into the parent folder and then shift back down into the raw folder. So you're giving the path here. So you're shifting up and then back down, basically. So this was the answer, and you were on 100% the right track, Yandile. So that's great. I'm glad that people are understanding this. That's fantastic. And thank you, Okut, for putting the solution on the chat as well. That's awesome. Okay. So it seems like, conceptually things are going well. That's always good to see. I'm going to stop sharing now and shift back to my terminal. Let me also just clear my terminal because there's a lot going on here right now. Okay. So we use the MV function well, not a lot, but we've used it a little bit now. There is also a copy command, which is just CP. Okay, so let's just quickly take a look at what's here now again. So we've got quotes.txt, which we just moved there just in the previous portion of the lesson. So let's say we want to change the name, the file name of quotes.txt to quotations.txt. Now you've seen before that you can use the mv command for that. The cp command can also be used to do something like that. Only with the mv command, you're replacing the current file and changing the name. Whereas with copy, it works like a regular copy and paste where it's making a copy of the file, but the original file will still exist. So let's demonstrate that. So if I did cp, and remember, I can see quotes.txt from within my current working directory. So I can just call it quotes.txt, and I'm telling it to copy this file into thesis, the thesis subdirectory. Let's say put it there. And we're going to call this file quotations.txt. So what's cool now is I'm going to copy this file into thesis, but I'm also renaming it at the same time. So I'm actually doing two steps with this one little sort of command on the command line. So let's see what happens. Let's just do an ls on thesis and see, okay, it exists now, quotations.txt. So the copy command is very similar to the move command. It's just that with the move command, often if you had run something like this, it probably would also work. But with the copy command, it's always making a copy of the file. It's not deleting or rewriting the file, which sometimes it does with the move command with mv. Yeah, I'm trying to think if I'm explaining that poorly now or not, but let's see. I think you all understood that, right? Did I explain that okay? I feel like maybe I didn't explain that well. Okay, I'm seeing some thumbs up, so I'm going to go with, okay, I explained that okay. Yeah, if I explain anything poorly, just stop me. Sometimes, yeah, I also feel like I explained something poorly, and yeah, sometimes I get a bit sidetracked in my mind. But okay, cool. Next, we're going to show you that you can also copy a whole directory using what we call the recursive option, which is usually when you use this sort of option, -R, that usually stands for recursively. So what recursive just means is from the lowest level up to the highest level. So say you've got your, say you run anything and add the -R command, and you say you're in the desktop and you're telling it to run recursively. What that means is it's going to start with the lowest level of your file structure, which on this path, for example, is writing. It will run it on writing, then run it on exercise data, then run it on shell lesson data, then run it on shell lesson data, then come back to desktop. So that's what they mean by recursive, from the bottom level up. So if we have, for example, okay, let's just do an ls, see what we have here now. We still have quotes.txt and we've got thesis. But let's say we wanted to now, let's say we wanted to make a backup of our thesis directory. So we wanted to copy our whole thesis directory essentially into a new directory with whatever else it contains. You could then use this copy -R, because remember, recursively means from the bottom level up. So it will copy absolutely everything that exists in thesis into the new file. So let's see, cp -R thesis. So what I'm saying here is copy recursively the directory thesis, and then we need to specify where it needs to copy to. So it's copying to a new directory that we are creating called thesis backup. We want to make a backup. So let's click enter and see what happens. If we now do an ls, we see we now do have a thesis directory and we have a thesis backup directory. So let's do an ls on both thesis and thesis backup. See if it allows me to do this on this command line. Yep, it did. Okay, so we'll see that inside of thesis, we've got quotations.txt. And inside of thesis backup, we also have quotations.txt because remember we made a complete copy, a recursive copy of the thesis subdirectory. Sane, go ahead.
If you didn't give it the recursive command, would it just have copied like a blank directory? Like it would just have made another folder?
Exactly, that's typically what happens. And sometimes it might even return some other errors, like it will tell you that the directory is not empty. You're not actually trying to copy an empty directory. So it would kind of warn you as well, like, hey, there are some files there. So let's just see if we did it quickly. So if we did cp thesis underscore backup.
Maybe backup 2. Oh,
No,
okay.
it's fine. You see
the R,
there,
yeah,
it
the
actually
R
tells
already
you.
breaks it. I see.
Yeah.
Okay.
Yeah.
So that
Exactly,
I guess is a bit different from how if we're dealing with a GUI file folder manager.
Exactly.
We would be used to, if you can copy an entire folder, it's always recursively. So this is important to remember. Cool.
Yeah, no, that's exactly right. So what Windows, for example, what the GUI systems do that you don't see is they are copying recursively when you move a whole folder. You don't see that because you don't tell it that. It's just an inherent thing that the GUIs do. But with the command line, you actually have to tell it. But what I like is that it kind of returns and says, hey, -r isn't specified, so I'm going to omit this thesis directory because it's already telling you there are things within the directory. And maybe you don't want to copy that. Maybe you do want to copy that, and you need to go and specify what exactly do you want the machine to do. So I think it's quite useful, but it's also cool when you start to see things like this and you'll start to think about even your GUI systems differently, because now, for example, you're always going to know when I move a folder, actually Windows is copying recursively by default. It's cool. I think it's cool. It made me look at like the GUI systems very differently, but cool. I'm glad you caught that as well. That's cool. Like you're making the connection between the two systems. And now you can also maybe see why sometimes Windows can actually be very clunky. Like when you get used to coding and everything, most people say they hate Windows, they hate the GUIs. It doesn't work well. And maybe now you might understand a little bit why they say that. Yeah, go ahead, Yandile.
Can you please explain the recursive again?
Sure, not a problem.
When you said it does what you're asking it to do for every level, do you mean there's a thesis backup in all desktop, shell lessons data, exercise data, and writing, or is it just underwriting?
No, so it will still just be underwriting, but I'm just gonna stop sharing. I just want to see if I can share the full picture of the folder structure that we shared before. Just give me a second. Under the navigating files and directories, I just want to pull something up because maybe if I speak through it visually, it might help a little bit. So let me just come back to this. You remember we did this example just earlier today. It wasn't, a lengthy discussion, but let me think if I can explain it sort of using this diagram instead. So let's say that within this file, you were in thing, okay? This is where you are located. These are all the files that exist below it, right? When you say copy thing, so let's say you did thing and you did a thing backup, backup of thing. You want to copy all these contents that is inside of thing to the backup thing. What the -r does or tells the system is copy everything from the lowest level. So from these file levels down and whatever it contains, copy all of that into the new folder or the new directory that you're creating. So recursively, when I say from the bottom level up, it means from the bottom level of that file system.
Okay.
Does that make a bit more sense now?
It does, it really does. So if you didn't include the recursive command, it wouldn't copy everything, it would just copy the directory itself and make a copy of it.
Exactly. So it would want to just copy thing. But now what I was demonstrating before, and let me just shift back to the shell quickly. So what I was demonstrating before is when we try to run that copy command, and we didn't specify the -r. You can see here, we didn't do it for this run. It returned an error that actually said -r wasn't specified and it's omitting that directory. So it's actually not making the copy. So the command line will usually do this when there are files within the directory that you want to copy. It will tell you, you didn't specify this. So it basically doesn't know what you want to copy. It doesn't know whether you want to copy just the file, just the empty directory, or do you want to actually copy all the files that exist within the directory. So it warns you, and it actually said omitting directory thesis, which says it's not going to copy it at all. So at least you understand what recursive means. And hopefully you understand sort of the error message as well. Is it a bit more clear now?
Yeah, I understand it now. Thank you.
Okay, cool. Perfect. That's awesome. Okay, great. So let's carry on then with this portion of the lesson. There is actually a little exercise that they've given you where you can think through this conceptually a little bit more. So let's do this exercise. Again, I'll give you a few minutes. And then when you have the answer, you can raise your hand or type it in the chat box, whichever you think the solution is. So let me stop sharing again and just flip back to the website. So we are working with files and directories. So this is the example over here on working with files and directories that I'd like us to look at. So again, I'm going to talk us through the example, and then I'll just sort of keep quiet for a couple of minutes. And then you can let me know when you get to the solution and what your solution is, and then we can again have a chat through it. So they give you the scenario that suppose you created a plain text file in your current directory to contain a list of the statistical tests you will need to analyze your data, and you've named it statistics.txt. After creating and saving this file, you realize that actually you misspelled your statistics.txt file name. You now want to correct the mistake. Which of the following commands would you use to correct your mistake? Would you use CP, the incorrect spelling, and turn it to the correct spelling? Would you use MV and fix the spelling that way? Would you use this command? Would you use this command? So think about what these commands are telling you to do, and then think about what the scenario wants you to do. So all it basically wants you to do is to convert or change the name of this file, essentially, right? Because you made a spelling error, you just want to correct the spelling. Now think about which of these you would use, and then let me know either via the chat or you can raise your hand as well. And then we'll move on to some more moving and copying examples. Okay, I see something in the chat. So lots of people saying to MV, wrong spelling, to correct spelling. Okay, I think we have a unanimous vote for 2. So let's see the solution. Yay, you are correct. So you can see here they give some explanations for why the others are not correct. So obviously if you had used CP, it would create the file with the correct name, but the incorrect file would still exist, right? So remember, CP copies the file, but it doesn't replace the file. Now we wanted to correct the spelling, which means we wanted to replace the file. So that's why the MV command did work. This does something completely different. This also does something completely different. This is not what we wanted to do. And so that is not correct. Okay, perfect. So now we can move on and do a little bit more practice with moving and copying. So I'm going to share my bash shell again. Okay, let me also just clear again so that we have a nice clean screen to look at and work with. Okay, so we've worked a little bit now with creating files and directories. We've moved a few files and directories, but now we want to remove some more files and directories. I'm just going to demonstrate this very quickly. I just want to see what the example is that they give here. so that I don't make up anything quite funny. Okay, it is what I had in my mind. Okay, great. So let's just do a quick ls again. So let's see if we can remove this directory, the thesis backup directory. Remember, before we did use the rm command, we used rm and then we gave it the name of a file. So let's maybe remove quotes.txt. Let's see what happens. We're going to remove quotes.txt. If we do an ls, it has removed that. That was simple enough. Now let's do an rm thesis backup. Let's see what happens. Now it's giving us an error. It says cannot remove thesis backup. It is a directory. So here's where things become a little bit interesting. Remember before we spoke about copying things recursively? When you use the rm command and you use it on a directory that is not empty, it will usually prompt you and say, we cannot remove this because this directory is not empty. So when you want to remove a directory with a whole bunch of subdirectories, again, you're going to use that recursive command or flag or option. Sorry, it's an option. You're going to use rm -r, and now you're going to do thesis backup. And now again, what's going to happen is it's going to remove things from the bottom level, from the lowest level up again. So, okay, this only contains one file, so it's just the quotations.txt that needs to be removed. And so once it removes that, thesis backup then becomes an empty directory, and then remove will remove it. So again, I hope that's not too confusing, but let's just run this quickly. Now when we do an ls, we see it has removed thesis backup. So before it complained because the directory was not empty, but now it's removed it because we added that -r flag. There are also other options that you can pass. So there's this option called -I, so that's remove something interactively. It's always a good idea to add this -I option as well, because then it will ask you, are you sure you want to remove this? So if I said rm, let's actually just maybe make a quick file so I can just show you. So just do another touch my file.txt. See there, the file is there. So let's do rm -I, and we're going to do my file.txt. Let's see what happens now. Can you see what happened? It's now checking with me, do you want to remove this regular empty file called my file.txt? Then I can say yes, and then it's been removed, but it's prompted me first. So whenever you use the rm command, it's always good to use -I. And if you're deleting a folder that contains other things, always got to use the -r, because that tells it to remove things recursively. Okay, I hope that's fairly clear and that's not too unclear. Okay, can I just get maybe a quick thumbs up if that's all clear? Yeah, okay, awesome, awesome stuff. Wonderful, that's fantastic. I'm glad people are not getting lost with this lesson. That's awesome. Okay, so I think what we can do is do the next example, which will also teach you something slightly new, and then we can move on to using wildcards. And then we can take a quick break again and then come back for pipes. So let's maybe not take too much time, but again, I'm just gonna stop sharing and then just share the website again. Okay, so we've made it all the way through this, and now I want us to, perhaps as a group, but also slightly individually, I want us to just cover this example, because I find this to be a nice example. Right, so they firstly say that for this exercise, you can test some of the commands in this directory. So remember, we've been in the exercise data directory this entire time. inside of the exercise data directory, you can then execute some of these commands and they should work. Okay, so I'm going to also demonstrate it for you, but I want you to just try this on your own firstly. So once you're in exercise data, the first thing that they want you to do is type in make directory, basically mkdir backup. Then they're telling you to copy something from the subfolder called creatures into backup, right? Then they are asking in the example below, what does CP do when given 3 or more file names? So you'll see here that it's actually been given 3 file paths or names. So it's asking you what exactly does CP do when you give it 3 or more file names. Okay. Or 2 file names and a folder. So look at what it's actually doing. It's also then asking you to change directory into creatures, ls-f. You should see this as an output. And then it's asking you to just type CP and 3 file names and see what it says. Okay, so I will do this with you in a second. But maybe just get started. But I'm going to pull up my terminal again and let's do this together as a group. Let's see what happens. Okay. So they are telling us firstly that we need to be in the exercise data folder. Remember, we've been working in the writing data folder. So how do we move a level up? We type in cd ... We move 1 level up, ls. And now we see we are back in exercise data. And here is the subfolder they are talking about called creatures, right? Remember earlier, we also made a directory called project and we put data and results within that directory. So that's still there. We didn't remove it. So that still exists there. So you should all be seeing all of what I see on the screen at the moment. So once you are in exercise data again, hopefully you've all managed to navigate there now. You're now going to make a directory. This is following the example, remember? Going to make the directory called backup. Let's do a quick ls. Let's just check that it's there. Okay, it's made the directory backup. Fantastic. It's now saying to copy creatures, which does exist here, and we can see creatures there. So it's saying take creatures and Minotaur. I'm going to tab complete because my spelling is terrible. And take creatures unicorn.dat and put this into the backup folder. That is essentially what we're typing here. Okay, so we're saying copy minotaur.dat, unicorn.dat into the backup folder. So let's see if it does that. Let's do an ls. Backup is there. So let's do an ls on backup and see what's in backup now. We've got minotaur.dat and unicorn.dat. It has copied that over for us. So the first lesson here is that if you've got CP, you can specify multiple files as long as the last file is the folder where you're copying to. Okay, I hope that's not confusing. So you can use the CP command to copy multiple files into a single folder, as long as the last thing on that command line is the final folder where you're copying to. If you don't specify that, it's going to do something slightly different. So that is what the rest of the example is actually demonstrating. So let's change directory into creatures quickly. Let's do a quick ls. We see basilisk, minotaur, and unicorn. We copied these two just earlier. So that's where they came from. If we just say CP, so let's copy minotaur and unicorn, and let's say we add basilisk as well. So the final name here is now actually not the folder where you want to copy it to. It's just another name that we're passing it. So let's see what happens. It's actually telling you that your target, which should be the final file name here, or folder directory name here, is not a directory. So it's actually giving you the warning, and it's actually done nothing. So if we did an ls now, everything's the same. If we change directories and move one up and we do an ls, everything's the same, right? So it's warned us. So that's a good rule to remember, that when you're doing copying of multiple things, you can specify really as many as you want, many files as you want, as long as at the end of that list, you provide the location or the target where you want to copy to. So that's probably another folder name, but you must specify that. Right, so that's just a simple example for copying. There's one other thing we'd like to discuss with the sort of working with files and directories component of the lesson, and that's the use of wildcards. So you can't run this. I'm just typing it so in case maybe I don't pronounce things too well. Wildcards. So we call them wildcards because they do something very different within the command line. So there are two wildcards that I'm going to touch on today, and that's the asterisk and the question mark. Why can't I find a question mark on my machine right now? Wow. There we go. An asterisk and a question mark. These are two key wildcards that you will use going forward. And basically what a wildcard is, it is a character that can match 0 or more characters. That's not going to make a lot of sense until I show you some examples. So I will show you a couple of examples soon. But this is the distinction between the asterisk and the question mark. The asterisk will match 0 or more characters, so any number of characters. The question mark will only match 1 character. That's not going to make a lot of sense yet, but let me demonstrate it with an example or two. Right. We are in our exercise data, and you will see this sort of subdirectory called proteins. That's the directory that we're kind of going to sort of work on for a little bit. And I'll just show you how to use it. I just want to find an example that's maybe not too complex, that won't confuse anyone. Yeah, so let's just go with the very basic example that they give here. So let's look inside of proteins quickly. I'm just going to do an ls on proteins. Okay, we have cubane.pdb, ethane.pdb, etc., etc., etc. Let's say we wanted to bring up anything that matches or that ends with .pdb. You can specify that you must, remember I said that the asterisk matches 0 or more characters, any number of characters. So we could have just said asterisk.pdb and this is, well, let's change directory. I might confuse you guys a little bit here. Let's first change directory into proteins. I think this will make it a bit easier. Do an ls, we've got that there. So let's just say, I'm going to use a little command that we haven't used much yet. It's just echo, so it's just saying basically print to the screen anything that matches star.pdb. So you see there the wildcard tells the shell that we're matching any number of characters and any characters before the .pdb, and we get cubane, ethane, methane, we get everything in the list, right? Because we said match anything that could exist before the .pdb. But now we could have said match. So I'm just printing to the screen using the command echo. Let's say match anything that starts with a P. So we're specifying that it must start with a P, but beyond that, there can be anything, but it must end in, say, for example, .pdb. We press enter, it now only returns pentane and propane because we specify P, so it knows it's looking for something, a file name that starts with a P, and then we've given it the asterisk, so it's matching any number of characters, hence giving us pentane and propane. and then it had to end with PDP. So that's how you would kind of use wildcards within your script. And I'll do 1 or 2 more examples so that you can also see how you would use the question mark. Because remember, I said the question mark only matches 1 character. So that's the key difference between the asterisk and the question mark. So let's show you an example of that. So if we had said echo, say ethane dot PDP, and we've just added the question mark, which tells you it's only going to match 1 character, right? There's only 1 file name that matches these parameters, and that's methane.pdp. So that's what I meant by it only matches 1 character. If I had typed in an asterisk there, so if I had said echo asterisk ethane.pdp, it actually returns ethane and methane, and that's because this matches 0 or more characters. So there's nothing in front of ethane, so it returns ethane and methane. So that's just a little bit of wildcard characters. If it's not too clear yet, again, hopefully when we use it in more examples and as the lessons progress, it will also become a little bit more clear. And there are a couple of examples that also exist on the page that you're welcome to maybe work through during the break as well. And then you can come back and let us know if you have any issues. So maybe what you can do when we go onto a break, so we'll break for just a quick 15 minutes or so now. I don't think we need to have a lengthy break. And then we can finish up the last section we wanted to cover today, which is just pipes and filters. So maybe what you can do during the quick break shouldn't take you very long, maybe 5 minutes. So maybe we should actually have a slightly longer break. But let's just try a very simple example. Let's just do the very, very first one. Because we were in the proteins directory now, so you should know where that is. So they basically just say that when you run the following commands in the protein directory, which ls commands will produce this output. So I've basically already showed you that just now, but it was basically just saying which command would have shown you ethane and methane. So it's basically using the wildcard characters. So the example I showed you is slightly different, but there are many ways to get to the same answer, of course. But think about this again. Don't click on the solution yet. First, think through these commands. Which command here would produce this output on the proteins folder? And you can even run them and see what happens. And then after the break, when we come back, you can let us know what was the correct answer. When we come back from our break, we'll cover pipes and filters. It's not a very long lesson. But again, sometimes it does take a bit of time to get through. So we'll get through this still today, and then we'll stop there and we'll continue on tomorrow. So there's not too much more coming. So hopefully you're not too tired yet. I'm going to just switch to the timer so that you know how much time you have left for the break soon. So let's take, let's take about a 15-minute break and then we come back. So we'll come back around 12, more or less. Maybe the timer might go off a little bit earlier, but let's come back at about 12, if that's okay. Okay. Thanks, Nikita. Okay, so we are almost at the end of today's portion of the session. The last sort of portion of the lesson that we'll cover pipes and filters. So up until now, we've done a lot of just navigating through the file structure, understanding the file structure and how it, looks within the command line, just understanding how to navigate. And then we've just done a couple of things, in terms of creating some files, moving some directories, creating some directories, and so on. So we haven't done too much, but we've gotten a feel for the file structure at least, and hopefully you've all been following along and navigating through your file structures and so on, and following the lesson. It does, I get the impression that most people on the call have, which I think is fantastic, because honestly, the best way to learn any coding language is by doing. And it's only by doing that you're gonna, learn those little nuances about the language, where your space needs to go, how, when you need to put a comma there or full stop there, etc., etc. So we've done quite a bit of navigating and so on. So now we're going to move on to pipes and filters. Before I share my terminal, I'm just going to share my screen again and then just pull up the pipes and filters lesson so that you get a feel for what we're going to be covering right now. So up until this point, we've run pretty much sort of singular commands. We've had a command, we've had an option, and we've run it across one or more files. But up until this point, we haven't really strung any commands together, right? So remember, right at the beginning of the lesson, we spoke about how Unix and the command line is a scripting language. That means obviously you can build scripts, you can piece things together, you can create long, long scripts of hundreds of lines of code that you can run with, one line in the command line and so on. But how do we get there? How do we start to string things together? We have to start from the basics, of course, once again. So we're going to take you through some very simple examples of how you can start to combine a lot of commands and start to form some scripts. So these examples are very straightforward and very simple. We'll cover 1 or 2 exercises depending on time. I do know we need to finish at 1. But I'll try and get through as much as possible while still giving us time to do at least 1 or 2 examples. If we don't manage to finish this entire lesson today, I think it's okay if some of it spills over to tomorrow. There's only a couple of lessons that I want to cover tomorrow, a couple of things, and a couple of those lessons are fairly short. So if anything isn't completed today, we can spill that over to tomorrow. So I'm not going to rush through this. I'll take my time. And if you want me to speed up, you can tell me to speed up. If you want me to slow down, you can tell me to slow down as well. Not a problem. Okay. So I'm going to switch back to my terminal now. Hopefully you can all get your terminals open again. I'm just going to clear the current view so that we have a nice clean terminal to start off with again. Now let's just do a PWD. Let's print our working directories. We ended off before we went on break within the proteins folder, if you recall. I hope you are all still within that folder. If you are not, just take a couple of seconds now to navigate there. So just shell lesson data, exercise data, and then proteins. So make sure you're within that folder. I'll just pause for a couple of seconds. I know that sometimes we close our terminals and then when we open it again, we're back in our home directory. So let's navigate there quickly. Okay, hopefully you're all there and it's okay for me to get going. So let's just start once again by, sorry, I'm just going to close my emails again. I know this gets annoying when this pops up the whole time. Sorry about that. Let's do an ls again. Okay. This is what we saw with our last example, where we were also going over some wildcards, which I hope everybody is comfortable with. We're going to use a brand new command now that we actually haven't seen yet today, WC. It basically stands for word count. And you're going to run that across one of these files here, the Cubane. It's the very first file that I see on my list. It might be different on your list, but that's what I see. So you're going to run the WC word count, Cubane.pdb. You're going to press enter. And let's see what comes up. See, we have 3 sets of numbers and then the name of the file. So the first set of numbers just basically counts the number of lines in the file. The second set counts the number of words. And the last set counts the number of characters in your file. So lines, words, characters, and then this is obviously just the file name printed here. Now, in the previous lesson, we spoke a little bit about wildcards. So let's actually use a wildcard now, and let's see what happens when we use the word count function. So we're going to do word count. We're going to use the asterisk. Remember, the asterisk matches 0 or more characters. So any number of characters or no characters, .pdb. So we're saying everything that exists within proteins that ends with PDB, run the word count command on it. So let's do that. We click enter. And you will see now, for each of the PDB files, we've got the number of lines, the number of words, and the number of characters. You can see this file, for example, is actually quite large. This is also fairly large, but this is much longer. And so on and so on. Okay, so now we've used the wildcard, and you can see the impact of the wildcard now. Now it's looping over multiple files without you actually even using a for loop yet. It's already looping over multiple files because of that wildcard. Now we could also have combined this with another option. So remember, we often pass options to our commands. So let's pass the -L, and let's still use the star asterisk, sorry, .pdb, and let's see what happens now. So can you see what's different here now? WC -L asterisk .pdb. So what has this done now? It's changed the view and the output. It's very simple. Just let me know via the chat what you can see is different. Just lists lines. Yeah, perfect. Exactly. So now it's just listing the number of lines within each set. And remember, right at the beginning of the lesson, we showed you this minus help function, right? So let's see what other options we have. Remember, we did -L, so that only returned the number of lines. You could have done M, which would have only printed the number of characters. You could have done -C, which would have printed the number of bytes, and so on and so on. So just always keep in mind that the minus help option is always good. If you want to see, how a command works, what options you can pass to it, especially if you're new to it. So now you've already seen some other cool flags or options that you can pass to the command that will print your output in a slightly different manner. Okay, so I'm just going to clear this again so that we start off with a nice clean screen. So now let's do, for example, word count -L. What do you think is going to happen here? Do you think this is going to run? Do you think this will run within, for example, the current working directory? What do you think is going to happen? Again, you can raise your hand and just speak, or you can type in the chat box, whatever you feel most comfortable with. So I see some comments coming in, there's nothing to count. Somebody saying it's not going to work because there's actually no argument. Yeah, but let's see what happens now. So I'm going to press enter. Do you notice something different now? That is not typically what happens.
So it's continuing to run, but doesn't stop running, like it doesn't give an output.
Exactly. So this is something that's going to happen so many times. There's something that's maybe gone wrong in your command. You mistyped something, you forgot something, and now it just hangs and the shell almost doesn't want to do anything. It doesn't want to work. Usually you can get out of the situation by typing Control or Command and C. So I'm going to do that now, and you see there my prompt is back now. Remember, we said in the beginning that when the prompt is there with the text cursor, it's ready to accept your input. It was not, it was waiting for input to finish off the previous command before. So whenever you run into this kind of trouble where you've run something and now it's hanging, you're not sure what's happening. Sometimes it's also due to like resource issues on your machine. maybe what you're trying to do requires too many resources and now things are hanging, always just remember Control-C. It will clear what's currently running. So basically in the job, and it will return you back to your prompt. So it's always something good to have up your sleeve, because you can see even with something simple like word count minus L, when I didn't pass anything to it, there was no argument, no file for it to run on. It just froze, basically. It was waiting and waiting and waiting for me to tell it what to run on. And that's something that happens very frequently. Okay, so now let's get to the good stuff. Let's get to the nice, interesting stuff where we can start to string together some commands, right? We're going to now start to capture the output from one command and start to put that into another command or somewhere else. And we'll start with a very, very simple example. Let's start with something we've run before. So word count minus L. So we're printing all the lines in each file. So we did this just before. But now we're going to use the greater than symbol to tell the shell to pipe the output of that into a text file. So let's see what happens now. So what we're saying is we wanted to run this and take all the outputs from this run and put it into a text file. So let's see. We're still in our proteins folder here. Let's press enter. Let's see what happens. Let's do an ls. Okay, we see a file called lengths.txt now. Now I'm just going to use a simple function called cat. So cat just prints whatever's in a file onto the screen. So I'm just going to use cat to print what's in lengths.txt onto the screen. And we see it's taken all the outputs of this command and it's put it into this file called lengths.txt. So it's taken this output, put it into something else. Okay. That's one way that we can capture and sort of what we call redirect output into another file. That's a very simple example. I don't think anybody will be too confused with that example, but it can, of course, get a little bit more complex. So I just want to see how in depth I want to just go with this, just based on the time that we've got left, so that I can make sure I make it to the final section, which I think is important. So I'm just going to quickly skip the first example that they've got on this page, but you're welcome to cover that after the lesson ends, of course. And I just want to skip on to the next section. And we will do an example at least as part of this, but I'll try and do an example at the end. So let me just skip to the next section. Okay. So a command that we haven't really used before as well is the sort command, but we'll use that now just to show you an example of how you can use some output files as well and then run some more commands on it. So for example, the first step of this process was for us to count the number of lines that existed within each PDP file. We then put that into an output. The output in this case was a file called lengths.txt. But let's say we wanted to sort what was in that file. So let's say we did sort lengths.txt. See, it has sorted it now. It's got 9, 12, 15, 20, 21, 30, 107. So it's actually sorted it numerically for the most part. But usually what the sort command does is it sorts alphanumerically. So it would sort quite differently. I just want to see, let me just find this example that they've got here quickly. Yeah, sorry, the example that they've got here is now slightly different to the example that I'm trying to demonstrate. But anyway, let's not get bogged down on that. What I wanted to just kind of demonstrate to you is that usually when you run the sort function, it will sort alphanumerically. So what would tend to happen is the way that the files would sort would be alphanumeric. So if you had, for example, 1, then say 2, then 12, then 13, then say 4, the way that it would sort is it would sort 1, then 1, 2, then 1, 3, then 2, then 4, because it does alphanumeric sorting. And in order to do numerical sorting on a particular file, you usually have to add the sort minus n option, and then it would tell it to sort it numerically. So this example went a bit wonky here now, because when I did the sort, it actually already sorted for the most part numerically, but I can see why it's done that just because of the way the numbers are structured in here. Yeah, so let's do a sort minus n quickly, and let's parse length.txt and let's see. Okay. So this example's not working so well for me, but maybe it's working a bit differently for you guys, because I see, Sine, you're getting kind of the proper output. Maybe my shell is just doing something funny at the moment, but you're seeing what you should have seen. So thank you for pasting that onto the chat box. So if you could maybe just look on the chat box, if you ran sort across lengths.txt, it would usually have sorted the way that Sunday is displaying here, where you've got 12, then 15, then 20, 21, 30, and then 9. Because 9 comes after 3, so it's sorting alphanumerically. So usually what you would have to do is pass the minus n option. Oops, sorry, it's not reflecting. The sort minus n, and then it would have sorted properly numerically. So Sine, when you added minus n and then lengths, did it do what it was supposed to do? Did you get the proper output by any chance? Marius is saying you got the same as me. Yeah, so something has maybe gone. Sorry?
Mine reacted as we kind of expected from the example, that when I just sorted,
Okay.
I think I put it in the chat earlier, but then Zoom froze right after that and I had to leave. And come back. I don't know.
No, thank you. Thank you.
Did that go
So-
through?
I got the first.
I showed, and
Post.
I sent a message of like, because it goes 107, 12, 15, and then the 9 is right at the end, because
Yeah.
if you think of numbers in the alphabet, 9 is after 3.
Exactly.
But yeah. But I'm running on Linux, so this might be a Windows issue.
Yeah. Okay, thank you so much for putting it in the chat. So I hope you guys have all seen this in the chat. She had 107 total, then it had 12, 15, 20, 21, 30, and then 9 was all the way at the bottom, because when it sorts alphabetically, 9 actually comes after 3. But actually 9 should have been right at the top, right? So it's actually sorting alphanumerically. That's the default way that the sort function works. Thank you so much, because I was going to battle to explain this now. So thank you so much for pasting this. So then when you use the sort in conjunction with the minus n option and you run it on this file, what it then would do is then sort numerically, and then 9 would shift up to the top and your answers would typically be in sequence. Thank you so much. Yandili has done it that way now with the minus n. Perfect. Thank you so much. So Marius, I think the two of us are on Windows machines and we're using Git Bash, and maybe that's why the output has changed a little bit. I actually am just making a quick note on the side.
But I'm not actually on the Windows machine. I'm on a Mac.
Oh, you're on a Mac. It's also doing that. Oh, okay.
Yeah.
That's quite interesting. And you're using your default terminal on the Mac?
Yes.
Okay. Thanks for that, actually. I'm just making a note of it quickly.
So for your next
'cause I think-
workshop, you need to request everyone move to Linux before they join the workshop.
Maybe.
Maybe.
Don't know how
Don't do that.
popular would be then, but but yeah, this is good to know, because I will just also feed this back to them, so that they are aware that this is actually happening on a couple of the of the machines, and maybe we just need to adjust this example. But thanks, Ane, also for jumping in, and thanks Yandile also for giving us some of your outputs, because I think now people kind of understand contextually at least, or conceptually, sorry, what I was trying to explain. So I'm going to try and carry on with this example, and I hope that it works okay the rest of the way through. But there isn't too much left for us to do. So yeah, let's see how it goes. Yandile, you've got your hand raised. Sure, go ahead.
I'm still confused. How does it sort this? It's on Windows and I
Okay.
got the same thing. I'm really not sure what it's doing.
So what's happened is some of us, for some reason, this isn't what was supposed to happen. So I'm going to talk you through what happened and what was supposed to happen. And then hopefully it erases some of the confusion. So sorry about this. So usually when you run the sort command, it sorts alpha numerically. So what that means is numbers that start with a 1, it'll sort those together. Numbers that start with a 2, it will sort those together, then 3, then 4, then 5, then 6, then 7, then 8, then 9. Regardless of what's coming behind them, that sorter that sits right at the front will dictate how it gets sorted. So what was supposed to happen when you ran the sort command was the 9 was actually supposed to be at the end. It wasn't supposed to be at the top, because it was supposed to sort alphanumerically, which meant that 9 comes after 3 and it would sit at the bottom. But now, for some reason, when we ran this, it's already sorted numerically, so it actually put the 9 at the top. But in general, when you're working on a bash shell, especially on Linux and so on, and for the Linux users, this seemed to work the way that it was supposed to, you would actually have to pass another flag or another option, which is the -n option, to actually have gotten it to sort numerically. But for some reason, our terminals has just done that automatically. So it just kind of messed with the example and the demonstration. I'm not sure if that's clear or not.
Okay, no, it's clear. Thank you.
Okay, sure. Thank you. Yeah, so the example went a bit wonky, sorry guys, but hopefully you still got the gist of what was meant to happen and how these commands are supposed to work. So usually, at least I can say, if you're working up in the cloud that's running maybe say Ubuntu, then this is the way that it would work. It would sort alphanumerically unless you added the -n, in which case it would then sort numerically first. Okay. So let's carry on for now so that we also don't lose a bit of momentum. Hopefully the rest of the example, like I said, goes okay. But let's go on with the rest of the example. Let's just do a quick ls again to remind us of where we are. So we're in the proteins folder, and we've been working with this lengths.txt file. If we do cat lengths.txt, we've obviously got the number of lines within each of our PDP files, and that was an output from a previous command that we ran. So now what we're going to do is we've run the sort command now, even though it's gone a bit haywire. We've run the sort command, but now what we want is we want to have the sorted list within lengths.txt. So remember earlier I used the greater than sign to pipe output between files. So we're literally going to do that again, but this time we're going to say sort by numerically. That's how it's supposed to work anyway. Lengths.txt, and then put that into the file lengths.txt as well. So basically we're overwriting the current contents with just the sorted list. That's all that's happening here. And now if we do a cat lengths.txt, something has gone wrong. Let me just do a quick ls. Still have lengths.txt there. Just do something else here quickly. Doesn't seem to be anything there. It is weird. So something has gone wrong here in this process. I'm seeing another little glitch. So when I did sort -n length.text into length.text, it's actually deleted what's inside length.text. And actually not something I did wrong. This is something that could happen to you. Something has gone wrong here. It's overwritten. Happens, I guess happens. There's nothing we can do about that. But this is also just a warning for you guys. Yeah, same happened to you. Yeah. So this is just also a warning that sometimes when you are redirecting output from one command into another file name that is the same as a previous file name, you can have this happen where you actually overwrite everything and you end up with a blank file. So that can happen. So just be careful when you're using this greater than sign. Okay. It is safer to use a file name, but there's actually another thing that you can use. And then this brings me into this. So before, we just used a single greater than sign. We're going to do a couple of examples now where we use a double greater than sign. And we're going to see how this whole scenario and situation could have been a little bit different. Okay. So earlier, I did quickly use the echo command. So all the echo command does is it prints text back to the screen. So if I said echo command prints text, it just prints back the echo command prints text. So it's just printing back whatever I put basically next to it. So now what we're going to do is we're going to say echo the word hello, right? So it's basically printing the word hello, and we're going to put that into a test file. Let's call it test file 01.txt. Okay, so we're just printing the word hello into a test file.txt. This is slightly different to how we did it earlier. You might remember that earlier we did nano, but we want to demonstrate something else here very quickly. So we're using echo to print that, take that output and put it into a file like we did before. Okay, so now if we do an ls, we should see test file.txt. And then if we did cat test file, just to print back to the screen what's inside of test file, we see hello, right? So now earlier what we did is we ran some functions and we put it into the same file name that we had before. And it overwrote everything, right? It gave us a blank file. We went, uh-oh, something went wrong. Oh no, my file was empty. So to have avoided something like that happening, because what this does is it will always overwrite whatever's currently in the file with whatever's here all the time. You can use the double greater than sign. And actually what this means is don't rewrite it, append what's coming next. So make new lines and put the new data below the previous data, just append. So now we're going to do that quickly and we'll see how it works differently to this. So let's first do echo hello into our test file. Okay. We're going to do it with one greater than sign and we're going to just echo and we're going to do that just a couple of times. So let's do it. It's once, let's run it again, twice, let's run it again, 3 times. Now let's see what's in test file.txt. Even though I ran it 3 times, it's only there once. So it's rewritten hello every single time I ran it. But now let's say we did echo hello and a double greater than sign. And then I still gave the same file name. I'm gonna say enter. And let's run this now a couple of times and let's see what happens. Just running it 4 times. And now I'm gonna print to the screen. That's all that cat does. Test file 01.txt. So let's see what's in this file now. And now what has it done? It has appended. Okay. So I hope that this demonstrates as well why just simply redirecting output into a new file, especially when that file or directory is named the same as an existing file or directory, is dangerous. It's almost always going to overwrite wherever you put the data. It's going to overwrite whatever's in that file, and a lot of the time you can actually lose a lot of information. So when we are doing some loops and we're looping over some scripts and so on, which we'll do tomorrow, it's always a good rule of thumb to use the double greater than sign so that you're always appending things onto the same document and never rewriting things. So that was the main lesson here. I think that's fairly simple to understand. I don't think that's too complicated. We will do a couple of more sort of complicated examples. So let's maybe, I'm just looking at time. Let's see what we've got time for. Okay, we've got time for one quick example before I move on to pipes. So let's do this appending data example. Yeah, okay. I'm just going to quickly stop sharing and then just pull up the example that we can work through. Okay, so it's on the pipes and filters page. I'll pull it up, but in case you want to pull it up on your end, you can do that as well. So it's just this little appending data example. And as always, please don't reveal the solution yet. Let's first try and do it and let's see how we go. So they again just give this obviously example that you can work through. So they said we have already made the head command, which prints lines from the start of a file. Tail is similar, but prints lines from the end of the file. We didn't cover this in too much detail here, so I will do that with you in a second. And then they say, consider the file shell, lesson data, exercise data, animal counts, animal.csv. After these commands, select the answer that corresponds to animal subset.csv. Before we go through this example, let me demonstrate head and tail to you guys. I didn't demonstrate this because I had actually, I think, skipped over the example where they did cover a little bit of this, but it's very simple. So let's maybe cover a bit of this first, and then we can go through and we can look at some of these commands and what they do. And we can do this again as a group so that nobody gets lost. And I'm hoping that there are no issues with this example now. But let me just quickly switch back to my terminal. Okay, so I'm just going to do a quick ls. I'm still in the proteins folder. And what I'm going to do is I'm just going to sort of use the head and tail command on the links.txt. So just to remind you what's in links.txt, nothing right now. So I have to just repeat the commands that got me that file quickly. Totally forgot we overwrote it. So let me just backtrack quickly. Sorry about this, guys. This example has just gone completely wonky at the moment. Okay, let me just see where I am. Okay, so because I'm using the greater than sign, it's obviously going to overwrite what's in there now, but there's nothing in there now, so I guess that's fine. Okay, so this is sort of where we started. So let me just quickly demonstrate the head and the tail command so that you can work through the example. Hopefully this isn't throwing anybody off too much. Okay. So let's just run the head command across lengths.t. And let's just see what comes back first. And then I'll talk you through what the head command usually prints out. So usually what the head command prints out is the top few lines of a file, while the tail command prints out the last few lines of a file. At the moment, we don't have a lot of lines, so it's printing everything, but you can also specify lines that you would like to print. So the -n here refers to the number. So you can say, give me the top 2 lines of lengths.text, and it will only print the top 2. You can say head -n, say you want the first 3 lines of lengths.text, and it will print that for you. That's you know, in a nutshell, how the head command works. It usually prints the top few lines of whatever file you pass it to, but using this -n and then specifying the number of lines you want it to show, you can control how many lines it also prints back onto the screen. And in the same way, tail works. So tail prints from the bottom of the list. So in a similar way, you can tell it, print the last 2 lines in lengths.text, for example. And you can see that it's printed the total and it's printed propane, because in the list that I've got at the moment, that's the last 2 lines. So very, very simple. If you pass tail -n3, again, it will print the last 3 lines for you. So that's very simple. Apologies for skipping that earlier, but hopefully now that I've done that, we can sort of move on to the example that they have, and let me talk through it a little bit better this time. Okay. So I've just quickly demonstrated the head command as well as the tail command. So they operate quite similarly. You can specify the number of lines that you wanted to return from either the top or the bottom of a particular list. And that is quite simple. So basically, what they are saying is we should essentially go into exercise data. That's where we've been working the whole time, but this time we're going into a slightly different folder called animal counts. And there should be a subfile in there called animals.csv. Okay, now they are saying, look at these commands and then select the answer that will correspond to the file animals subset.csv. The way that they've worded this, I think, is a little bit confusing, but let's look at the commands and then let's look at the options. So they are saying you need to look at the head of animals.csv, and let's pretend this was piped into animals subset.csv. So let's pretend this file was created, and you've taken essentially the top 3 lines of animals.csv and you've put it into this file subset.csv. Then you've gone and on the same file taken the last 2 lines of the file. And actually what you've done here is you've appended it to animals subset.csv. Right. Now they are asking you basically what's in the file at the end of this. I've basically told you, but they're basically asking you what's in the resultant file. Is it the first 3 lines of animals.csv? Is it the last 2 lines of animals.csv? Is it the first 3 lines and the last 2 lines of animals.csv? Or is it the second and the third lines of animals.csv? So we know from what I've described earlier. So I'm going to check the chat. Yeah, number 3, exactly. The first 3 lines and the last 2 lines of animals.csv. So this was just an example to kind of show you how you can use the append function to pull out subsets of data as well. So the head and tail command works well for subsetting data. Obviously, it can get a lot more complex than this. There are some other options that you can pass and things that you can do. But at a very, very basic level, that is sort of how the head and the tail command works. And you might come across it here and there. And here they've also just kind of explained the same thing here. They've also just said option 3 is correct. and then explained what would need to happen for options 1, 3, and 4 to be correct. So number 3 was the correct option. And so that was quite simple and straightforward. But that was mostly just to demonstrate redirecting versus appending. And so I think we get the gist of, if you redirect, you overwrite. If you append, you just add to the file. And this is a nice sort of technique to use for subsetting data as well, like we've done, like they've kind of demonstrated with this particular example. So now with the last 15 or so minutes, I'm just quickly going to run through pipes. It's not a very sort of lengthy portion of the lesson, but let's see if we can just get through that, because then tomorrow we can start with loops and scripts. So let me just share my screen. Okay, I'm still within the proteins folder. We're going to now show you basically how to take the input from one command again, and we're going to pass it to somewhere else, but this time we're going to pass it into another command. So before, what we saw was we redirected output into a file. So we ran a command, we used the little greater than symbol or little triangle, and we then took that output and we usually put it into a .txt file, right? So we just redirected the output. We then saw appending, where we added some more output, but we didn't erase what was there before. You also have this character called a pipe. So what a pipe allows you to do is, like I've said, take the output from one side or one command and pass it into another command. And you can string as many pipes and commands together as you can keep track of. So it's a very useful sort of technique and sort of method to use. And so let me demonstrate that very quickly. So let's say we did the sort minus n. I'll just carry on with the example like it is there, but obviously my terminal sorts numerically by default, but that's fine. So let's say we again ran this command, but unlike the last time where we redirected the output into a file, we are actually piping the output of this command into another command. So now we're going to use head. Remember, minus n1 is just saying, give me the top line, basically just the top one line. We're specifying that with minus n1. So we're saying sort numerically this file, take the output and pass it to head, and then give me the top one line. So let's run this now, and let's hope nothing gets overwritten. Let's see. There we go. The top line is methane after the sorting. That is correct. And it's just printing out the top line, which is just methane.pdb. Right. So that is just a very simple demonstration of a pipe and how it works. But let's maybe just do one or two more examples that you can follow along with. So again, let's use some commands that we've used before. So let's do word count minus L. So that's just going to give us the number of lines in each file, if you recall. And we're saying run this across all of our PDP files. We're still in the proteins folder, so we can just call the PDP files or specify them. And this time we're going to pipe it right into the sort command minus n. So we're basically doing what we did in the previous example, which is doing the word count, specifying we only want the number of lines in each of the PDP files, which we have specified with our asterisks. We're taking that output and we're piping it into another command, which is sort. So it's going to sort it for us numerically. Okay, and there it's done that for us in one line. But now similarly, you can string more than two commands together. You can string 3, 4, or 5. And so let's just do a quick example where we string more than two commands together. So let's add another one to the previous command. So we've said before we used word count minus L on all the PDP files. We push that into sort. And so now let's add another command. So let's pipe the output of sort, which is now the sorted PDP files, this output basically. Let's take that whole output and let's pipe it to another command. And let's do head -n1 again. So I'm again saying we just want the top line. Let's click enter. And again, you see here we've got methane.pdp. But what's interesting is instead of having to take all of these long steps that we took before, where we wrote out to a file, we then sorted, we then could run the head command on it, we can do it all in one line. So we've done everything we've done in multiple lines and iterations before, but we've done it just in one quick line. And this is where the command line really becomes really, really powerful. It's this ability to loop across things, but to string bits of scripts together, to take outputs from one command and pipe it into another. It becomes a really, really powerful tool, to be fairly honest. And you will see that as you use it a little bit more, it's maybe not as intuitive when you first start working with it, but over time, you know, it becomes actually a really great resource. So I don't know if we want to maybe just do one quick example for pipes. Or if you guys are okay to end there. We have actually covered quite a bit today. So maybe you might want me to rather just do a quick recap of some of the commands that we went over. Or do you want to do maybe one more example? So it's up to everybody in the group and how you're feeling. I'm feeling a bit tired, to be honest. So I'm not sure if you guys are feeling okay. Yandile, go ahead.
Oh, I'm asking about the combining of the pipes. Could you add what are those things called? The greater than sign?
Yes, you
Could you
technically
add it
could.
to
Yeah. So you could. So I can show you an example maybe. So I could have done, say, word count -l dot pdp, and I pipe that into sort -n. I could have then said, put this into new file dot text. Okay, do an ls. I now see new file dot text. Let's see what's in there. And there we go. So you can use a redirect within the command string or within the script. So that's very possible, yes.
Okay, thank you.
No problem. I did see somebody else unmute. If there were maybe some questions. Okay, I'm just going to quickly pull up the chat. Okay, so I see one question from Maurice asking, does word count count the number of words or lines? So the way that word count works, if you just run word count on the file, it will print the number of lines, words, and characters, I think. I hope I'm not misremembering. I think it's lines, words, characters. But within our examples, what we've done is we've used word count. Let me just show you here quickly, word count, but we've added this -l option. So what the -l option does is it tells it, do the word count, but we only want the number of lines. So we asked specifically for the number of lines. So I hope that that's clear. Sure. And like I said, at any point, if you want to try and recall how things work, you can do -- help. And it will give you some information about how it functions and how it reports. So it will say line, words, and characters or byte counts. So it does give you that kind of information if you use -- help as well. Okay. Okay, I haven't seen any votes for doing another example. Maybe an example with pipes. Or if you guys are okay to end here. For now, not sure how everybody's feeling. you're feeling okay. Are you feeling overwhelmed? I think you all pretty much managed with the lesson today, but was it okay? Was there something that maybe wasn't explained well? Maybe tomorrow I can go back over it if we've got a bit of time. Okay, Okert is saying, I'm also tired, so we can end. Yeah, I agree. We've been on the call actually a long time now.
I see that there's a few more exercises on the page. Do you suggest we do that on our own, or will we do that tomorrow? Like there's an example, pipe reading comprehension that looks interesting. What should we do? I like the idea of ending as well. I should say that. It's been great, but it's long.
Yeah, I know. It's been quite the number of hours we've been on the call now. So let me say this. I also like this example, actually. It's a really nice example to use. So what I'm going to do is I'm going to stop sharing and just switch back to, I've pulled up something funny here. Let me just go back. Okay. So on this page, pipes and filters, towards the end, you'll see a lot more examples. So we obviously are never going to have time to go through all of these examples. But these are examples that are intended for you to practice once you end off with the carpentry. So you can go back and you can go over this. But what we can do is we can work through a couple of examples. I think we've got the time actually tomorrow to do that. So I think that would be fine. So let's say this example, pipe reading comprehension. Maybe you guys can go home and try this on your own. Maybe you can try it tomorrow morning, even before you join the session. It's not a very complex example. You just have to basically build up this little pipeline that will do this, right? Okay, maybe it is a bit complex. But what we can do is try it on your own. We'll come back tomorrow morning. We'll see if anybody has resolved it. Don't look at the solution yet. We can then see how people have gone about this, compare some answers, and then we can run through this as a group as well, and then look at the solution that the Carpentries has given. If you want to do another 1 or 2 examples then tomorrow morning, that's also fine. We can do that. But perhaps you can let me know tomorrow morning. So then tomorrow we'll basically start off around here, Nell's pipeline checking files, and then we'll move on to loops, and then we'll move on to how you can find things within your file structure and so on. We'll do a little bit of scripting, but we're not going to do a heap of scripting, so don't be too concerned about that. It's very simple. Just gonna write a very, very simple script and then get it to run on our file system. So that shouldn't be too complex. So yeah, let me know, I guess, tomorrow morning how you feel. If you feel comfortable with the content, if you want me to run through some of these examples, maybe we can spend the first 30 minutes or so running through some of them. But let's at least all try and do the pipe reading comprehension. Let's all try and do that. This can be the one example we run through tomorrow as a group, at the very least, unless you tell me you want to do more. Is that cool? Is that a plan? Is that okay? We all try and do this, and tomorrow morning we can start off by discussing this, and then we'll carry on from here. Is that okay?
I don't see anyone saying no.
I was about to say silence means yes.
Right. Thank you so much, Verena. It's been I've enjoyed our first day. Yeah. Cheers, everyone. Is it cool if we start leaving?
Yeah, no problem. We'll see you guys tomorrow. Thank you for everybody for staying on the call. And we'll reconvene tomorrow 8:30. I know it's early, but we'll see you bright and early at 8:30. Bye, everyone.
Bye.
Bye.
Bye.